మీకు టైం కనిపిస్తుంది అలాగే.
Hi there.
Good afternoon, Adam.
Hi, Bjesh. Can you hear me okay?
Yeah. Oh, yes, definitely, yeah. So, most welcome.
Excellent.
So we'll start on time.
That's very good.
the mic. Two minutes. Start.
Good morning, participants. I request all the participants to please keep their cameras also on mute so that they have a better bandwidth and they can enjoy this session in a flawless manner. I repeat that I request all the participants to please keep their cameras on mute or switch off your cameras so that you can have a better bandwidth and you can enjoy this session in a more flawless and a more adequate manner. Thank you.
Sunny, not the speakers, but not the.
Yeah, this is not for the speakers. This is for the participants only. Brajesh sir, Dr. Sharma hasn't activated his mic. He's only his camera is only activated. I request Dr. Sharma to please activate your mic, sir. Also,
Yeah.
You haven't Sharma sir. You haven't connected your mic. Just click on the mic icon on the screen. So
Good morning, Mr. Sharma.
Since his mic is not active right now, we are not able to listen to him.
No problem, but I can't see him also.
Dr. Pare will get in touch with Mr. Sharma privately and he will communicate the message. Meanwhile, I think it's time for us to start now. People can keep joining in. Okay. So hello everyone and a very warm welcome to this session of sustainability and 21st century skills. This international webinar is being organized by Quantum Vault and I'm the co-founder of Quantum Vault and your moderator for today's event. So before we start, I would like to give you a brief about who we are and what we do. So Quantum Vault was formed during the pandemic when we wanted to convert the despair, especially in the education sector, into an opportunity and develop a global cohort where there's a learning opportunity for both teachers and the students. So Dr. Pare here, he is the president of Association of Chemistry Teachers, and he has also been graceful enough to be the head of the academic advisory committee of Quantum Vault. So I would like to I would like him to share with us what he used to do before we started Quantum Vault and our network and association with academics. Over to you, Dr. Pare.
Thank you, Gargi, and I take this opportunity to welcome all my three revered guests, Dr. Sharma, Dr. Adam Lee, and Dr. Paul. So, in fact, apart from my job of teaching chemistry at undergraduate and postgraduate level, I have been always interested in popularizing science and chemistry. And with that, we have been doing Australian chemistry quiz in India since 2003, almost 17, 18 years. And this is a very popular quiz by Royal Australian Chemical Institute, Australia. Every year they conduct it in almost 25 to 30 countries. And the most important thing with the quiz was the quality of the questions. And the purpose of the quiz has been to inculcate interest in young students, the interest in science, and to fulfill that particular thing, with doing a quiz is a challenge. And so Royal Australian Chemical Institute has been doing it perfectly all right. And the quiz is like a jungle fire. Students from class 7 to class 12, they enjoy doing it. And the quality of questions are meticulous and wonderful. So we have been doing it. And from just getting inspired from that, we have been just asked by the students and teachers across, the globe, that why not we can have a more and similar kind of things for young students and teachers. So that is how we got inspired. Thank you.
Thank you, Dr. Pare, for your insight. So now, Odi, a little brief about Quantum Vault. We are based in India, but we develop programs keeping in mind the international community. Our focus is to have innovative events which instill 21st century skills and also develop learning of the students. We focus on the educators' skill development along with the students also, because we believe that only a well-equipped educator or teacher can then in turn equip the students. We are inspired by the words of Leonardo da Vinci, who said, "Learning is the only thing the mind never exhausts, never fears, and never regrets." That is, it's the most important tool we have today. What sets us apart is our work philosophy, that is combining the young energy with experience. Quantum Vault tries to get in touch with experienced and acclaimed pedagogists, academicians, and researchers, and combines their vision and ideas into practice and reaches out to a global audience. Our mission is to empower and illuminate and help introduce 21st century skills in both students and teachers, inculcate interest of students in learning, and to make it exciting so that even some technical subjects can reach the student's heart. Our focus is to build responsible global citizens. I would now give a small brief about our previous event, Quest for Questions, which was a web workshop of question designing for teachers. So we had more than 1,500 teachers participating in it from over 12 countries. It was a week-long program, and at the end of the event, we received over 1,000 quality questions, and 50 top questions were even awarded. Today, we are meeting for Sustainability and 21st Century Skills event. For this, we have received 5,700, more than that, registrations from 61 countries, which is really an enthusiastic response. And we have our 3 academicians who will be talking to us about the topics from Australia and Qatar. So our first speaker would be Dr. Adam Lee, who is a professor of sustainable chemistry at School of Social Science, RMIT University, Melbourne. Before Dr. Lee starts, I would like to say a few words as an introduction. Dr. Lee is a professor of sustainable chemistry in Melbourne. He is a PhD from University of Cambridge and has held academic positions at Hull and York universities, has held chair appointments at Cardiff, Warwick, Monash and Aston universities, in addition to the prestigious EPSRC Leadership Fellowship. He was awarded the C.R. Birch Prize by the British Vacuum Council in the year 2000, the Fondo Facella Prize of the Electra Synchrotron in 2004, the McBain Medal of Royal Society of Chemistry and Society of Chemical Industry in 2011, and the Paleby Medal in 2012. He has authored more than 250 articles and graduated 31 PhD and MSc students. We are delighted to have Dr. Lee with us today and eager to hear his thoughts about sustainability. Over to you, Dr. Lee.
That's great. Thank you very much for the warm introduction. And it's a great honor and privilege to be able to present to you today on some of my research and research generally in the field of sustainability. Hopefully, just to check, can everyone see my screen? Hopefully you can see the screen share.
Yes, we can see it. Thank you.
Excellent. Right. So I just need to, brilliant. I need to just move everyone out of my way so I can see. Right. Okay. So sustainability. I guess the first key thing we need to think about is what is sustainability? And so I'm just going to move things off the screen. There we go. So sustainability is in general defined as sorry, I'm just having to clear some things off my screen. As I've got some things on my screen at the moment that are flashing up. So sustainability is defined as essentially when society aims to meet the needs of the present, but does so without compromising the ability of future generations to meet their needs. And this terminology was first coined back in 1987, and most recently, it's had an impact upon the world in the form of the United Nations Sustainable Development Goals. So these are shown here. So essentially, we've got 17 goals, which the United Nations came up with, which span a whole range of different topics. I won't go through all of these right now, but just to show that there's a few, for example, the elimination of poverty, the attempt to provide clean water for the world, and, for example, looking at things like climate action as well. So attempt to try and eliminate climate change. And these essentially are targets that set society both challenging goals for itself, but also in the preservation of the so-called biosphere. Just trying to make sure that I don't have this. So I'm just going to turn off a little setting there so I can make sure everyone can see what's on the screen here, including myself. Right. Okay. So I'm just going to focus on a few of those goals throughout the next 25 minutes or so. Initially looking at particularly the food, energy, water nexus, as it's called. So the question here is about how we can try and address these challenges of ensuring we have food for all, sustainable energy going forward, and also clean water. And so these are three of the key UN Sustainable Development Goals that we've just looked at. How can we make more food or better use of food? How can we use water more efficiently? And how can we generate clean and renewable energy? And these three are all linked together. There's a strong interdependency between food, water, and energy. And these target a couple. As I go throughout the talk, I'll put up the little boxes here which show you which of the UN Sustainable Development Goals we're touching upon. So obviously food relates to hunger, but also responsible consumption. And there's a strong interdependence between these things, between food, water, and energy. And that's largely because if you think in a very simple context, what do we need to grow food? One of the key things we need, as well as fertilizers and additives, is water. Water is critical for food production. And in turn, the production of food therefore impacts upon the availability and the cleanness of water supplies that we have around the world. In turn, the energy sector is one of the biggest users of clean water. So we use water throughout the energy sectors, particularly in the fossil fuel industry. And in turn, food production and certainly processing of food is also very energy intensive. So there's a strong interconnectivity between the different aspects of food, energy, and water. And moving forward to try and make sure that we meet sustainable development goals, we're going to have to come up with ways to improve the survival rates of things like food, so the shelf lifetime and the degradation rate. So we need to have better pesticides and fertilizers so we can grow more and protect our crops. We also need to think about things like waste valorization. What do I mean by that? I mean trying to find ways to take food waste and add value to it. make it more beneficial for society. In terms of water itself, we need to find ways, particularly using chemical methods, to try and clean up existing wastewater streams. So effluent from industry often contains very toxic compounds that conventional wastewater treatment plants cannot decompose. So we need to find ways to destroy those pollutants. And then finally, we need to find alternative energy sources. And there are many different alternative energy sources that are being discussed around the world, including things like bioenergy, the use of solar, so sunlight to produce solar fuels, and I'll touch upon both of those. The production of hydrogen, there's a lot of interest now, particularly in Australia and in Asia and the US, in the transition to a hydrogen economy, so using hydrogen as a fuel source. And then connected with these three as well, we have to think about emissions, so particularly greenhouse gas emissions. Fossil fuel plants, as we can see here, generate a lot of carbon dioxide, and of course that influences climate change. So what we really need to have here is improved science, fundamental science approaches. So we need to have a better understanding of what's going on, for example, at the molecular level. We need better engineering solutions which implement the science. And we need these two technological approaches to be guided by social policy as well. So we need input from across the spectrum of pedagogy. I'm just now going to touch upon a little bit of chemistry, just as an introduction, to give you an idea of where one of the sciences is going, and just briefly introduce the idea of the 12 principles of green chemistry. We hear the word green used a lot in connection with sustainability. Essentially what we're trying to do, I won't go through all of these little things that are on the screen here, but essentially what we're trying to do is, in general, try to find ways to minimize waste production, so prevent waste being formed, and try and inherently design processes that start being safe for humans and safe for the environment, and processes that also use those ingredients to start with. So we're trying to make processes and products safer for ourselves and the environment. So I won't go through all of these. They're very well known, and there's some links here, some references to look at. One of these involves the use of a particular technology, catalysis, which is the core of my background and my research. And the catalyst is simply a substance, a material that speeds up, that accelerates, in general, a chemical process from the point of view of science. So the bottom line is that we have an invaluable guide really to improving resource use, the efficiency of industrial processes, and also health and safety. So if we can avoid using toxic reagents and we can avoid producing waste, we can hopefully develop more sustainable processes. So I'm just going to pick now the first of those topics I mentioned, food waste, and give you an idea of the scale of food waste and the impact that it has on society. So the United Nations Food and Agricultural Organization, FAO, estimates that last year alone, the world generated 1.3 billion tons of edible food waste, food that could have been eaten. We're not talking about packaging here or stems or rice straw, things that can't be eaten. This is food that could have been eaten. That's around a quarter of the total production of food in the world ended up being wasted. And when you look at where and how that food waste arises, you can see that in this case, there's actually surprisingly perhaps an awful lot of food waste is coming from developed countries, which is perhaps a bit surprising. So you might have thought that developing countries were producing most of the waste. In fact, it's the developed countries, typically viewed as the Western world, but that's a whole range of obviously societies now that have reached a high level, supposedly, of networking and transportation around the world. But still, we're suffering a lot. So if you look at the breakdown by region, you can see here actually the biggest wasters of food is in fact North America and Oceania, Australia, where I am right now. And in fact, if you look at the balance, the majority of food that's wasted in developed countries is actually wasted by individuals like myself in our houses. So the actual households are producing most of the waste. In developing countries, we find something quite different. In fact, the majority of waste is generated during the growth and harvesting and transport of food. So in either case, in both scenarios, there's a huge amount of waste that's generated. And particularly in developed countries, there really is no excuse. It's the individual that's responsible, the actual consumer. If I look just in Australia, there's a fairly recent report which highlights the problem. So I'm based in Melbourne, which is roughly down here, this little dot just there on Port Phillip Bay in Victoria State. And the average household now, so individual people in Australia and Victoria, about 14% of all food that they purchase ends up going into the bin, into landfill sites. It's completely wasted. So that's obviously a tragedy when there are people who don't have food around the world. As well as the loss of food itself, if you look at the economic cost, That costs the world about $750 billion is lost through that food that is not actually going to its target, being eaten by people. Along with that, there's a huge footprint, as it's called, a huge carbon footprint. So the production and transport of that food actually takes about 3.3 billion tons of CO2. So a huge amount of this greenhouse gas is released into the atmosphere for food that's never even eaten. So that really is a tragedy. So what can we do about that? How can we, hopefully you can see at the bottom of the screen now, how can we add value to this unavoidable food waste? So there always will be some food waste, the inedible parts. So things like shells, straws, stems that are produced during agriculture. How can we try and at least get some value out of that? So I'm going to show you a couple of projects here now that are trying to turn some bread waste into useful things using chemistry in this case. So there are tens of thousands of tons of bread waste produced in every country around the world every year. And there are now methods to take this bread waste, which is rich in carbohydrates, things that our body needs, and proteins and fats, but principally carbohydrates and proteins. And those carbohydrates can be turned into concentrated glucose solutions. So glucose we're familiar with hopefully is a sugar, but as well as being a sugar, it can be turned into a lot of other valuable chemicals. So when you take bread waste, you can use chemical techniques to break it apart. We can use enzymes, for example, to break apart the chemical bonds. We can extract the oils, the proteins, and the glucose, the carbohydrate. And that glucose itself can then go on to be fermented to produce these molecules here, succinic acid and lactic acid at quite high yields. So for every gram of bread, you can make half a gram of succinic acid. And these materials are themselves very important as renewable, bio-derived, so coming from nature, not from fossil fuels, chemical ingredients that can be used in, for example, coatings and plasticides, polymers and packaging. So these sorts of molecules currently we have to derive from oil and coal. So we have to derive from fossil fuels, which means they're not renewable and the production of them is very dirty. We can actually obtain these valuable chemicals from something that's already being thrown away that we're not actually getting any value from. So that's looking at bread waste. We can also look at things that, again, are inedible. So in Africa, there's a whole range of crops where we harvest the crop part for eating, and there's a range of seeds and husks that are inedible. And they're often rich in very valuable chemicals, complex chemicals, which have, in this case, for example, in the case of neem seeds, which is grown widely across North Africa, we have medicinal properties that can be developed. So we can take the original seeds themselves, and we can extract the good bits that we want to eat. We can press the remaining pulp and husk and obtain an oil, and that oil can be processed to produce very complex molecular structures. But these molecules are actually very valuable. They can be used, for example, as pesticides, or they have medical applications, for example, as antiseptics or antihistamine treatments. So to make these chemicals from scratch in the laboratory is incredibly labor intensive and resource intensive. Nature has already done it for us. We just need to find a way to extract and use them. Another project shown here, these projects, I should say, were supported by the Royal Society in the UK, is to look at castor oil seeds. Castor oil seeds are rich in a molecule called ricinoleic acid, which is actually extremely toxic to humans. So these can't be eaten. We can't drink ricinoleic acid. But molecularly, its structure is very similar to precursors that are used to make polyester fibers, to make textiles, clothing that we have. And so if you actually, again, press these seeds, you can extract a whole range of different high-value oils that can be used as lubricants and surfactants. So again, valuable chemicals that we can obtain. How do we currently do things in the world? How do we currently make molecules and products? Well, nearly everything that we have around us, pretty much everything you have in your house right now, if you're sitting in a house or an office, comes from fossil fuels, whether it's plastics, paints, adhesives, clothes, all are derived from fossil fuels, predominantly crude oil. We take crude oil out, we put it through a process called refining, and from that we can make things like fuels that we put in our vehicles, our cars. We can make solvents that we use to dissolve other chemicals. We can make things like alcohol, so we can have our drinks as well, our vodkas. We make chemicals, and these are bulk chemicals. For example, things like methanol. Methanol is an incredibly important both solvent but chemical in its own right for making larger molecules. We make polymer fibers from which we can produce tubing and piping or clothes. We can make carbon nanofibers for the next generation of phones and vehicles. The more valuable chemicals, things like pharmaceuticals, so medical supplies, and also lubricants and oils. This is how we currently operate in the world. This is an incredibly dirty process, and it starts from something that is not renewable. We're running out of access, I'll show in a moment, access to fuels that can be burned. So there's plenty of oil and coal in the world, but using it is a problem. So we want to try and move away from this approach using fossil fuels. So why is it, for example, in the production of just of energy, of heating our homes, why can we not continue to use coal and oil? Well, the big problem isn't that we're running out of it. If you look here, there's a recent study that shows there are huge reserves of fossil fuels buried underground. Unfortunately, if you burn these, so there's roughly 11 trillion tons worth of carbon buried underground. However, burning that would put a massive amount of CO2 into the atmosphere, which would mean that global temperatures would rise dramatically above the UN's target for us to manage climate change of 1.5 degrees by the end of the century. So the vast majority of these carbon-based resources cannot be used without destroying our planet further. So we need to find a transition. We need to find alternative sources of carbon. And you'll hopefully have heard of the low carbon economy, moving to carbon neutral kind of processes. So many things in nature, biomass, which means biologically derived carbon, things like algae, for example, or food or agricultural waste, are very rich in carbon. And there's now a movement to transition the way that we make products and molecules around the world from using fossil fuels to biorefining, taking biomass in all its forms and producing the same kinds of outputs. These are things that are used to make products that we use every day in our homes. These are numbers just for Australia to give you an idea of the scale of the waste that exists unused right now. In Australia, we generate 370,000 tons of biosolids from things like water treatment plants that's unused. We produce 13 million tons of waste from homes, residential waste. This is not just food waste, but it's a large part of that is food waste. 13 million tons of waste just in Australia. In terms of things like tires, why do we care about tires? Tires are made of carbon. Carbon allows us to build all of these molecules here. 390,000 tons. So there's a massive amounts of waste resources that exist around the world that are currently not being used. Just to give you an idea of the impact using those wastes could have, here's some values for Australia. It's estimated that if we switch to using these resources, Australia alone from the bioenergy sector, so making energy from these sorts of materials over here, would generate $5 billion, 10,000 new jobs, and save $1 billion that we currently have to pay to put these waste sources into landfill sites or to burn them. And again, that's a tragedy. So there's huge opportunities to move to sustainable processes. Being able to, of course, generate your own fuels, for example, in the case of Australia, is very beneficial because it improves our liquid fuel security. Australia imports nearly all of its jet fuels, or imports fuel that we process to produce this. So we don't have our own main source of petroleum. If we can generate it from waste, it means that in terms of energy security, a country is much happier. We can also produce things like hydrogen from this. And finally, also new types of materials, which will actually be more beneficial for the environment. We can make plastics and polymers that are biodegradable and naturally break down and don't harm the environment. Okay, to do that, however, we have to develop new kinds of chemistry and new engineering approaches. And the key focus here really is here of trying to minimize additional waste production. If you're starting with a waste resource, you don't want to make more of it, and try and improve the efficiency of processes. What do I mean by that? I mean using less energy and trying to make sure that all of the molecules that you put in to your reaction end up in the final product that goes to the customer. So just to give an idea of the kinds of transformations, there are many naturally occurring plants, so jasmine flowers, for example, which contain valuable molecules, which we can extract if we use a catalyst, and in this case, just air, a very clean reactant, air is all around us, and we can make high-value chemicals, for example, things like cinnamyl alcohol turning into cinnamaldehyde, which is a key ingredient of lots of fragrances and perfumes and also food additives. So we can make one kind of chemical transformation, and we can go further. We can do an additional chemical transformation and make even more complex molecules, like, for example, cinnamic acid, which is a precursor to an artificial sweetener you may have heard of called aspartame. So we can do these transformations backwards and forwards. We can take hydrogen out, we can add hydrogen in. But these sorts of chemical transformations using biologically derived resources are difficult. So we have complex reactions, and so we really need new kinds of technologies to allow us to convert biomass into chemicals and to fuels. I'm not expecting anyone to necessarily understand the next slide. I just want to give you an idea of how far advanced science is now. So here's an example of a catalyst that was made by some of my research group a few years ago. And it illustrates how we can generate complexity in chemical materials that are human-made that begins to rival nature. We can make catalysts, for example, materials that have holes which are only a few hundred nanometers across, smaller than the width of a hair. We can put different kinds of elements into them. For example, we can put palladium and platinum into them in very complex structures. And those complex structures allow us to do interesting transformations. So here, for example, we can take an architecture made of silica, a very cheap and abundant element. We can introduce metal particles, these are platinum particles. We can add another kind of element, palladium, which can do a different kind of chemistry. And we get very fine control over these at the nanoscale, the nanometer scale. So we're beginning to advance technologies to the stage where we can say, make materials and processes that rival nature. And that allows us to be selective. So again, here's some chemistry. All you need to know is that the green is the molecule we're trying to make. It's a high value product. And by conventional technologies, you can make only a small amount of it. The green bar is small. With advanced technologies, these very controlled architectures that we can build in laboratories, we can make a lot of this product. And so we can now do multi-step complex chemical transformations to make high-value products from molecules that are around us in nature naturally without having to go to fossil fuels. And so these so-called nano-engineered catalysts allow us to get really good control. Why does that matter? Because being able to make only the green product here means we can avoid waste. We have a selective process. We produce only one molecule with no waste. Here's another example of using a similar catalyst. There's a huge amount of waste cooking oil generated around the world. It's very difficult to do anything with. It's very viscous and very dirty. It has a lot of impurities. These impurities are called free fatty acids. And it means that we can't do anything with the waste oil unless we can find a way to remove these impurities. It turns out that you can build the technology that can do just that can turn waste cooking oil into biodiesel. So a bio-derived fuel that you can put in your vehicles. Again, there's some chemical transformations. You don't need to worry about what they are, other than we can make now a catalyst, a material that can drive this chemical transformation to make the molecule we want that you can put into your car. And we can make a catalyst that can also remove this. It can do this chemical transformation simultaneously to destroy the impurity. So you have catalysts where you have very complex control over chemical transformations that allow us to now have a situation where this unique catalyst here, we add an impurity and its performance remains unchanged. So here's a measure of performance. The bigger the number, the better the catalyst. Normally, a catalyst that you could go and buy from a commercial supplier would be killed immediately. If you try to add this free fatty acid, this impurity, this new catalyst is extremely tolerant. What does that mean? It means you no longer have to send your waste cooking oil into a large production and processing center. It means that someone who is running a small restaurant and producing this waste themselves can take one of these catalysts and they can add it using materials chemistry, and they can locally produce their own source of fuel. So if you're a farmer and you're in the middle of the field and you're not well connected to the electricity grid, you can now actually take things like waste cooking oil that you produce naturally when you're cooking on your stove, and you can make your own diesel in your own location without depending upon some large petrochemical company. So that's a big advance. Okay, the final topic that I'd like to touch upon is using sunlight. So it's again an energy related topic, but in this case, we're not looking at biomass. We're not turning to biological resources that exist on our planet. We're turning to sunlight. So why sunlight? Why does sunlight matter? Well, sunlight's an extremely powerful energy source. You may not realize it, but when you actually look at the numbers, there is enough sunlight reaching the entirety of the Earth, so all of the Earth, not just the land bits, but the sea as well, to power the planet for an entire year. So just think about that, 430 exajoules of energy. In 1 hour, the sun provides us with the energy for the entire planet to be powered for 1 year. Now, of course, we can't harness all of that. Much of the sunlight is at the extremes, at the poles. So we have colder areas here, less sunlight. But we have many regions, particularly obviously in Africa and here in Australia, where we have a huge amount of sunlight reaches the Earth's surface and can be used to drive technologies for sustainability. Let's just give you an idea of what sort of technologies I'm talking about. Okay, one of them you're probably familiar with, solar panels. So we're used to the idea of taking sunlight and putting it into some sort of thin sheet of material that we can buy now. These are commercially available. And those thin sheets involve typically a material like something called a perovskite, They involve a collection of atoms of different elements that are assembled into a certain unique structure. And when sunlight hits those materials, it excites electrons, and those electrons can flow around the circuit, they can move around the circuit and generate electricity. So this is direct energy to electricity conversion. So we're familiar with that. However, there are issues because the efficiency of these solar panels, their conversion levels that you buy, are not very high. In a laboratory, you can get efficiencies of sunlight to electricity conversion of up to 30 or 40%. The ones that you can go and buy and put on the roof of your house are much, much lower. And the other thing to bear in mind is that the ones that are made currently, solar panels, involve very expensive or exotic elements. So we need to find a way to improve the existing generation of solar panels for power generation. We need to move beyond the current solar panel technology. What else can you do with sunlight? Well, rather than making electricity directly, you can actually do chemistry. Why would you want to do that? Well, in some cases, if you generate a lot of electricity through a wind farm or a solar panel, you do not want to use it immediately. You'd like to store it. And actually, one of the best ways to store excess energy is as, for example, hydrogen. So you can basically turn out electricity by splitting water. You can use electricity to break water into hydrogen and oxygen, and you can then store that hydrogen as a fuel source. So literally as a liquid fuel, you can pressurize it. And then when you want the electricity back, you can put it into a fuel cell and produce electricity out of that. So you now have a high density means of storing and transporting energy as hydrogen. Hydrogen is also a very important chemical. So we use hydrogen in many chemical processes to transform oil into plastics and adhesives, additives of all sorts, fibers. The other thing you can do with sunlight is, so that's water splitting to make hydrogen. The other thing you can do is take light energy and turn carbon dioxide from the atmosphere directly into a hydrocarbon. What's a hydrocarbon? It's simply a collection of carbon atoms with hydrogens attached to them, which is the basis of things like diesel and petroleum. Fuels, things we're used to. So valuable products we currently get from coal or oil, we can get from carbon dioxide directly using only sunlight. What else can we do with solar energy? And of course, the key thing about solar energy is it's free. It's free, it's abundant, it hits the planet, whether we like it or not, all the time. Sometimes it's cloudy, as it is today in Australia, but even then, you're still getting enough sunlight to do a certain amount of chemistry. The other key thing you can do, as well as making energy and molecules, is you can destroy things. You can destroy things you don't want. So you can also take sunlight in combination with certain materials. Again, these are called photocatalysts. Photo because they accept photons, they harness photons of light packets, and they do chemistry with it. What chemistry would you want to do in this case? We might want to purify water sources. Solar energy is actually very powerful, although it doesn't feel it to us. At a molecular level, it's very powerful. And when coupled with a catalyst, it allows us to break down, to decompose, to degrade things like molecules that are harmful, volatile organic compounds, things like benzene. So benzene is toxic, we don't want to breathe it. Nitrogen oxides, these are emissions from cars. But it also allows us to break down pathogens. So it allows us to kill bacteria, germs, whatever that means. It's a rather general term, fungus. And if you look down here, most importantly, things like COVID, so viruses. So we can destroy a broad range of pathogens just using light energy, nothing else, no extra energy input, and the right kind of catalyst here. So we can use it, say, to clean up water. That could be water that's naturally occurring in rivers, or it could be the effluent stream from industry. The textile industry, actually particularly in India, is very bad at putting chemicals, not deliberately, but releasing small amounts of chemicals from the dyeing processes where you color fabrics into water streams. So just to say before I move on to that, I'm going to show you an example in a second. For all these examples here, we must try and improve process efficiency. How much light does it take to make an electron? How much light does it take to make a molecule of hydrogen? How much light does it take to destroy a virus particle? So we've got to improve efficiencies, and we've got to try and find a way to get away from rare elements. And I'll say about that in a moment. So industrial effluent streams, I said. So typically, when you have a dyeing of a fabric, if you want to make your clothes look orange or red, you'll use a dye. And unfortunately, the river, the water that is used to produce that fabric, the dyeing process, ends up being released into the environment. So it looks like this. Very unpleasant and very toxic, many of these chemicals. We can now build catalysts in the laboratories. This is a catalyst made by one of the researchers who used to work in my group here. So this is a catalyst made of copper, a very cheap and abundant element. And when you add that copper catalyst into some water which contains these toxic dyes, it can decolorize them. It breaks the molecules apart, it destroys them. And you can even now think about building a process where you have this catalyst in a series of tubes, So you flow through the wastewater, which has these organic pollutants, these colored dyes. This one here is called rhodamin B. These are toxic materials. You can flow them through a tube containing the catalyst particles, and the output, you get clean water. So we have a very efficient water purification now. So photocatalysts can purify these sorts of industrial effluents using only sunlight and a catalyst as the input. No electricity, no natural gas, so very efficient processes. I'm just going to start finishing up now by pointing out that all the processes I've just described depend upon having access to elements to make your product, to make your catalyst, to make the wires that connect things together that electricity flows through. And here's a very interesting look at something we don't often think about. We think about the periodic table shown here, that we have these elements on the planet Earth and that we can use as many of them as we like. That is not, unfortunately, true. So what we're seeing here is a coloration of the periodic table based upon how many years of each of these elements we have left on the planet at current rates of use. So some of these metals we're familiar with: gold, platinum, iridium. These are so-called precious metals, or at least these ones are precious metals, these are noble metals. So precious metals, because they're very rare, they're very scarce, which means although they're very good at doing chemistry and making molecules that we want, we don't have many of these elements left on Earth. Cobalt is particularly bad because cobalt is used widely in battery technology and mobile phones. It's mined from the mineral coltan in the Democratic Republic of Congo. There's huge issues associated with its extraction, damage to the environment and the harm to the people around, but it's also in relatively short supply. These numbers to us look okay, 5 to 50 years, that sounds good, but the whole point about sustainability is we don't care about just us, we care about the generations who come after us. So we have to care about the future generations. So many of the elements we're running out. So I'm just going to summarize now where I think we need to be looking in sustainability. We need to start viewing waste as a resource, and it's always going to be produced, so it's a sustainable resource. Humanity will always make waste. So whether that's plastic, food, or greenhouse gases, CO2, we have to find a way to take these waste sources and transform them into valuable products, not simply abandoning them. We have to try and, alongside that, make a transition from something called a linear economy, in which we take resources from the environment, we make a product, and then we throw the product away. That should never happen, but it's how society, how mankind has lived for thousands of years. We need to move away from that to a circular economy, where essentially we make something from waste, we use it, and then we recycle it to remake the same product or a different product. So this is my very end of the slide. So literally the very last thing I want to say is that how do we achieve all these things? Well, the starting point will be education. We have to improve education globally in topics like climate change and awareness of the importance of biodiversity and of habitat protection. So we have to get that message across around the world, especially to the younger generation. I'll stop there now and just thank all of my colleagues that I've worked with over the years, particularly Karen Wilson at RMIT and Scott Valentine, who's been an inspiration for me in this area. That's it. Thank you very much. So I'll stop the screen share, but I'm happy to take any questions.
Yeah.
Yes, we can have a couple of questions for Adam on a raise hand basis. So Sunny, our administrator, will help us with this. You can raise your hands now if you have any questions for Dr. Lee, and we will.
We already have some hand raised, so I randomly I am selecting 2 people.
Yes, yeah, 2, 3, yeah.
Yeah.
Please go ahead.
So. Sandipta, I have raised, yeah, please unmute yourself. I have requested you to unmute yourself. You can ask your question. Sandipta, do you have a question? Okay. So,
Sudipta, I think Sudipta Dev.
Sudipta Dev.
Yes.
Sudipta Dev. So she's not responding, I think so.
Leo?
Yes.
Yeah.
Yes, sir. I don't have any questions, sir.
So,
Okay.
okay, that's fine.
Okay.
You had your hand raised.
Okay.
Okay, you can put your questions in the chat box. We'll enable the chat box, and Dr. Lee can then later take on your questions from there.
Okay, sure, ma'am.
Yeah, yeah.
Very happy to. Or if anybody wants to and send me an email, if they have any questions or anything I've spoken about is of interest to them, please just drop me an email. I'm happy to try and assist however I can.
Yes. And we'll also make Dr. Lee's presentation available as he had requested. So we can make it available through a Drive link, and we'll share it with the participants. So, Dr. Pare?
That's a very, very mesmerizing presentation and talk by Professor Adam Lee. He's a wonderful scientist, but looking to the participants, he has just simplified the whole thing, and the take-home message today is waste is a sustainable resource. That is a wonderful thing. And a wonderful presentation. He started from how the braid waste, can be converted into succinic acid and into lactic acid. Later on, the seeds, the neem seeds can be converted into pesticides, antiseptics. And moreover, air is a clean reagent, that's something beautiful, we need to know that how the air can be used, as in place of the other catalysts. And similarly, how to harness the solar energy. So wonderful, thing. And thank you very much, Adam, because really, you are a wonderful researcher. You are doing a lot of things on green chemistry and green science, produce so many good papers, but at the same time, just looking at the need of the participants. And see, even those who are not having even a science background, they must have enjoyed your talk today. And please keep guiding us, keep encouraging us, keep coming to us. Thank you very much. I'm really, really indebted. Thank you very much.
Hello, sir. Hello, sir.
Yes.
Hello, sir.
Mr.
Hello.
Do you have any questions?
Yes, sir. Yes, ma'am. I would like to ask Lee, sir, a question about this sustainable, this one only, sustainable chemistry only. So can I ask a question to sir?
Yes, please go ahead.
Sir, your session was really wonderful and a very good eye-opener for all of us. And being a student of science, I just would like to know the method which we are going to adopt, that sustainable chemistry and conversion of waste into something which is really useful for the society. In that, what about the economic part of it, where it is going to be, suppose if it is cheaper, it will be always be better for countries like ours. And second thing is, what are the possible side effects of it, which are going to cause once again harm to the nature?
Okay.
So the first question is an excellent one. One of the things people always get hung up on, they always obsess about, is trying to make sustainable products cheaper. Now, and the reason I say this is something that's very important to look at is because we forget that the fossil fuel sector is one of the most subsidized sectors on the planet. In other words, governments around the world give fossil fuel companies huge amounts of money to operate. So when someone's trying to compete, for example, if you want to make biodiesel or a biofuel, it's always very difficult to match the price alone, because your fossil fuel competitors, the people who make the petroleum normally, are getting a huge benefit already. They have a huge advantage. However, there's two things to bear in mind. One of which, of course, is that when we have CO2 issues, climate change, that we have CO2 credits, there are now financial incentives to try and move away from fossil fuels. So that's the first thing, is that there is now a shift in policy around the world where green, sustainable alternatives are finding more support from governments. And the other thing is that I only became aware of recently, of course, is that when you have a waste, you have to pay someone to take that waste away. That actually waste costs people. So not using waste costs a huge amount of money. So in Australia, companies have to pay a lot of money to the local states and to the government just to transport and to bury their waste. So actually you save money indirectly. So if you use waste as a resource to make a useful product, you don't have to pay someone for taking your waste away. So there are economic benefits. It is difficult, it will take time, but we're seeing already now the cost of green hydrogen, the cost of making hydrogen is from renewable methods, so using electricity and sunlight, for example. People think will cost the same amount, it will be directly dollar for dollar competitive with fossil fuels in about 15 years at most. So we're very rapidly approaching a place at which renewable products, sustainable products, cost the same as fossil fuel ones, despite fossil fuels having these huge subsidies. So that's a big benefit there. Apologies, I've forgotten your second question. What was the second question?
Thank you so much, sir. Thank you so much.
You had a second question as well, Mr. Kumar?
Yes, ma'am. Second question was about during this process of conversion, what are the side effects of it? Are we not going to encounter waste, dangerous materials released out of these, which are going to harm once again harm the nature?
Yeah, you're absolutely right. So a key thing, a transition. So green chemistry idea is, I guess, 20 plus years old now, and there's a big movement now to moving from green, which is good, to sustainable. What's the difference? Well, and these are not my ideas. I have to say this is really John Warner and Paul Anastas who've been driving this from the start. The idea is something called benign by design. Literally, you go to a blank piece of paper and you start from scratch. You think about where are you going to get your starting materials, your chemical precursors from? How will they be transported? How will they be processed? What solvent will you use? What temperature? Where will the electricity come from? You think about every step along the way of making a product. You then think about the consumer. How will they use it? And you then think about the end life. What happens when a product like a television, what happens when it's no longer of use? And so you start trying to design products and processes such that they can be recycled. You make a molecule of plastic so that when it's finished, its useful lifetime is ended. You can easily put it in water or shine a light on it, and the molecules will break apart and discretely go back to their starting points. So the whole point really is to try and make sure that the new processes that you develop use solvents like water that are safe. They work at low temperatures and low pressures, so you're reducing hazards there. And that you're not just looking at just the chemical process, you're looking at where the molecules come from and where they will end up when the product is finished. And that product could be a plastic, it could be a paint, it could be a tablet, a paracetamol, for example, some antibiotic. So the key thing is not to start jumping ahead and just trying to change one thing only, but it's to think about the holistic approach. The entire process has to be thought about to make sure you don't actually end up making something worse. You make a side effect which is worse than the original process you're trying to replace.
Thank you so much, sir. Thank you so much.
We have a
very
couple
much,
of other raised hands, but I would request all of them to drop their questions in the chat box, where Dr. Lee can then have a look at them and maybe answer them in the chat itself, so that we can move on with our other speakers. And since we're talking about sustainability and Dr. Lee being from Australia, I would like to mention that I recently read in the news how Australian government is investing about $190 million in recycling of the wastes, and they have actually set a timeline from January 2021 to somewhere in 2024, where they'll be banning a certain amount of products, and there will be enormous benefits coming out of it, how Dr. Lee answered about the economic benefits. So the government believes that this entire process would be creating more than 10,000 jobs in Australia. And it will also improve the quality of life, since there will be reduced carbon emissions, and they'll be turning around 10 million tons of waste into some useful products as well. So that's an exciting move by the Australian people. Okay, so the place where Dr. Lee stopped, that we should educate the new generations,
yes,
in order to bring about a change in how we are dealing with environment and to take forward sustainability. We have launched this event at Quantum Vault called the Enviro Quiz. Just give me a moment. I'm not able to move my slide forward.
yes, yes.
So the Enviro Quiz is what we are talking about here. It is a quiz on environment and sustainability. It is an international online proctored exam, which will be held on 5th and 6th of December for students of grades 3 to 10 globally. So you can give this exam from the comfort of your homes with no risks involved due to the COVID-19 era. And our aim with this quiz is to take the message of sustainability and environment wide across the globe and to make this an interesting and intriguing topics. We'll develop intelligent process-based questions. We'll be using Bloom's taxonomy, which will then enable, this will be a learning tool for students and not only an assessment tool. This will raise the students' awareness level and also excite them to be intrigued by the sustainable development and environment. So you can always know more about this quiz from our website, Quantum Vault. And along with this, we are launching another event. And my slide share is again stuck out. Please cooperate with me. Yes, so along with this, we have another event coming up called the Sky Pie Quiz, which is an international science and mathematics quiz. So as Dr. Pare had earlier shared that we have been associated with the Australian National Chemistry Quiz, that is ANCQ, from the past couple of years in India and the Middle East, we received a lot of requests from educators and teachers and principals at school level that there was no such event which was testing in a holistic manner, which was enabling the students to learn in a holistic manner. And that is important. So we decided that in the lack of such an event, we'll come up with a quiz that talks about science and maths both, and also aims at developing the 21st century skills of critical thinking, logical reasoning, data interpretation among students. The exciting part about this quiz will be the quality of questions used. The SkyPie quiz will again be an online proctored exam where you can participate from anywhere in the globe, from the comfort of your homes, and you will be proctored during the examination. It's for students from grades 5th to 10th, and it will be held on 12th to 13th December. The good part about both these events, the Enviro quiz and the SciPi quiz, is that you'll be receiving a very elaborated result report, which will enable you to look at your shortcomings and develop them, identify them, and also to build on your existing strengths. So on this note, I would like to invite our next speaker, Dr. A.P. Sharma. And before he comes and enlightens us with his thoughts about the 21st century, I would like to say a few words to introduce him. Mr. Sharma is a science graduate and an MPhil in economics with over 30 years of experience as a leader and academician. He is a CBSE and National Award winner from President of India in 2012. In 2015, he received the Global Teachers Award. He was also the Academician of the Decade in 2016 and was awarded the Women Empowerment by UNESCO and Delhi Commission for Women. He has received many other awards, including Exemplary Leadership Award by the President of India in 2018. He is an expert on design thinking and is working for spreading awareness about latest pedagogical techniques. I now invite Mr. Sharma to guide us forward towards developing 21st century skills for both teachers and students.
Thank you very much, Gargi ji. And first of all, Dr. Brijesh Pare, welcome, Mr. Adam Lee.
Thank you, sir.
And all other people who are on the panel, and especially all the participants. I'm overwhelmed and I feel humbled by this introduction, but I'm just like a teacher, like all of you are listening over here. It is just a matter of 10, 20, 30 years that adds some kind of awards and all, but the best award is when child appreciate your work. That is the best award, even better than the President Award or any other award. So what I will do, first of all, I will talk on 21st century skills. And then I have a small presentation on design thinking, because that is my forte. And that is one of the most important skill which will be in the 21st century as well in 22nd and 23rd century and all the centuries, because this is something which is going to be there for years and for eras and till the human civilization is there. And there is a possibility of improvement in human civilization and all the works. So first of all, let us come to 21st century skills. It is very interesting to know that even after 20 years of 21st century, we are talking about 21st century skills. We could have talked about these 21st century skills in 2001 or 2002 or something like that. This means still we are in the process of creation. We are in the process of retrospection. The problem is all the countries are coming up with new education strategies. Like India, right now they have come up with a new education policy 2020, which has come after the 36 years above the previous policy. And the basic idea behind all these policies are that how to inculcate education in a proper way. Now, I will take up certain kind of beautiful things which you will like. So after a wonderful session of Mr. Lee, I think you need some kind of games can be played. So just I will share my screen and we will play some quiz. So as I said, first of all, I thank you all the teachers and salute a significant Corona warrior community working from behind the curtain. So basically, the idea behind this is that how you can really proceed further. And processing just I think my slide has also been blocked. So just a minute, please, because some problem in this one. So can you see my presentation? Mr. Parekh, can you see my presentation?
No, sir, not yet.
Okay. Now can you see?
No, sir. Mr. Sunny?
No problem. I will do it again. So it will come. Now you can see the without slideshow. I will keep it without slideshow for one reason, so that I can see other things.
Sir, it is coming up, sir, now.
Yes,
Now it is coming up.
Coming up, yes, sir, please.
So I would like to see the chat also. So basically for that reason, I'm keeping it like this. So
okay.
Bear with me. So I'm asking one question and you can answer in chat box. Let's be thoughtful first. Please pick one deal. If one $10 voucher is given free, will you go for this? Or one $20 voucher is given in $7. So if you go with A, just in chat box, type A. And if you go with B, then in chat box, type B. So I can see in the chat box, it's coming A. Yeah. Mostly coming A's. Yes. So mostly A answer is there. So very correct, because we are getting free $10 and $20 voucher we are getting in $7. And this is the problem, that in thinking process, we get somewhere stick to basic idea of moving away. Now, if you will find here that the right answer is $20. Why? If you look at point of saving, then the $10 means you are saving $10. In $20, you are saving $13. Because if I ask you second question, that what will be the situation when suppose the things have changed, and according to the text, if we go for the $20 in $7, or maybe the $8 and $10 in $2, so the things will change. But simple thinking is that whenever we are talking about 21st century skills, we have to be very careful, and we have to be very careful about one simple thing, that we should be thoughtful. Similarly, in this era of 21st century, we generally know about 4 C's, which is talked. For example, the critical thinking, creativity, collaboration, and communication. These are 4 skills which we talk about the 21st century skill. But remember, nobody can give you the idea that what kind of jobs will be there, what kind of professions will be there in 2030. In 2030, remember one thing. Right now also, many teachers, they faced a lot of problem to go with technology. They faced a lot of problems related to the real deliberation of subjects and all. So whatever be the situation, a teacher can't be replaced by the technology. And simply, one more thing we can say, that in most of the corporate world, it will be the more efficient person who will replace the less efficient person. But one person will remain forever, and he can't be replaced, who is good in soft skills. So if I talk about 21st century skills, then I believe that there are 2 aspects of 21st century skills. One is soft skills, because it will continue to empower a person throughout. And what are these soft skills? Like, you should have a decisiveness, you should have a responsibility, you should have self-motivation, time management, and most important is conflict resolution. I can really guess. Somebody was telling that, okay, in one bank, it was observed that if, let us see, and let us do the experiment that we will do complete automation. And they did complete automation. So there were robots who were there, and wherever robots were not required, there were machines. So few people came, and then they found initially, okay, there is some problem, 1 day, 2 day, 3 day, 4 day. And they said, okay, let us change one robot with one person. And they changed. And there were many people who were delighted. So the manager asked one of the older lady, why you think, and which position or which situation was better? She said, sir, without robot, this one was better when the human beings are there. Why? Yeah, because, sir, when I'm coming to withdraw my money, this particular tailor is asking me, or the person who is sitting on the cashier counter is asking me, ma'am, how are you? And how is your child? And he knows about family. It seems good. And his smile is also good. But when we come in front of machine, just we take money and go. So this human touch should always be there. Similarly, the flexibility, of course, we talk about attitude, we talk about leadership. All these things which are related to soft skills are very important for anybody. Now, an important paradigm shift is required when we are in 2020 and we are looking at 2030. Then a paradigm shift in education is required. And what I believe, this paradigm shift depends upon certain kind of things. And this is that we have to move from fixed mindset to growth mindset. But before that, it is very important that we move from one particular thing to another thing, keeping one thing in mind, that we are progressing. If we do not progress, then everything is not useful. For example, if we talk about the purpose of education. So in most of the countries, in particular in India, it was like acquiring knowledge. And from acquiring knowledge to construct knowledge. If acquiring knowledge to construct knowledge is the journey, this means whatever rote learning you are learning, and then you are considering it as a tape recorder, and everything you are having in your brain, which can be released at another point of time. But I had a discussion with some educationists, and I told them that we have to move further. That is from knowledge acquisition to knowledge construction, and from knowledge construction to application of knowledge. So knowing everything is not important, to apply is more important. Then most of the education system, they stop here, apply. Because we talk even in CBSE and other ICSE and all, we talk about experiential learning, we talk about competency building, and we said that one child who is learning must know how to apply. But something is beyond that also. And I have added there that creation of new knowledge. You know it very well that if somebody is thinking out of the box, somebody is thinking how we can bring out some changes which are desirable and innovative, then only we can really produce scientists. Otherwise, we will produce followers. And everything depends upon just one basic skill, that is how we can think out of the box. And if we want to think out of the box, then we should change the concept of learning. It should not be what is a child is learning, but the more important is how the child is learning. So if we move from this, that what the child is learning from how the child is learning, then there will be more scientists, there will be more people who will be thinking creatively, who will be thinking out of the box. Why in Indian system, we had only one scientist, Mr. Raman, and there were many scientists who went to abroad and then they got Nobel Prize. Because there they got opportunity. Here we are limiting our education system to that particular concept only. Let me come to the screen share again. Now, observation is the key. James Watt observed the kettle, Archimedes observed the floating, and Isaac Newton observed the apple. Observation leads to thinking, and thinking leads to design. You know it very well. Many people with James Watt would have observed this kettle, but they did not thought of a steam engine or something like that. Similarly, Archimedes, he gave it a eureka moment, and he thought of how we can think about the purity. Isaac Newton, apple was there and man was there, and apple was falling on many people's head, but only Isaac Newton thought of it. So in education, observation and reflection is very important. We move to the next slide here. My God, why it's not moving? Yeah. So here, the next thing is that how the process of inquiry goes. Like we know that the art and science of asking questions that are accessible can be answered in part or in whole, and ones that lead to meaningful test and exploration. And that can involve careful observation and measurement, hypothesizing and interpreting. And so inquiry becomes the first thing that you start inquiring about any question, like in schools and classrooms. I don't think a classroom in which no child is speaking is a good classroom. A good classroom is that classroom in which children are asking questions, continuously asking questions and finding the answers. That is a good question. What is inquiry process? That scientific inquiry. This moves from defining, identify the problem, from a hypothesis, making observation. I came to know from a scientist, and we in Qatar, that time we were having junior science, junior science Olympiad. And the chairman of Science Olympiad, he came to our school and he was talking that, Mr. Sharma, from one particular experiment, we can have 100 to 150 observations. And he said, just how to prepare hydrogen in laboratory. And now what kind of observations are there? And then he started making observation. And there were more than 110 observations even in that experiment. So until and unless we make them skillful, and we make our children skillful to observe and identify certain kind of things, then without that, the process will not continue. Similarly, inquiry leads to surprises sometimes. Inquiry is a recursive, ever-revolving process driven by the learner's ideas, questions, and purposes. For learning begins with personal connection. Inquiry is experimental learning, leading to design thinking. Inquiry involves immersing children in a topic with time to explore, wonder, investigate, and research. Accidental inquiry leads to discoveries and inventions. You know about tire. how Dunlop got the tire. You know about you know about the Alfred Nobel's invention. All those inventions, they came by accidents. So even if you are ready to observe and you are ready to see, then you can find. I'm giving one more, the quiz to all the participants, and I would like to see in chat box. You can see this particular photograph, and you have to list 3 observations. And from observation, it is very important what inference we take. See, at the down, it is written, now that desks looks better. Everything squared away. Yes, sir, is squared away. And now try to find out what kind of observation you make. You make just one observation and put it in the chat box. You will find E is equal to MC7, E is equal to MC4. Very popular formula is written over there. So I see in chat box, few things are coming. Yes. So very interesting here is this, that in this observation, the observation was this, that this scientist told maybe his wife or maid that just squared everything. So what she did is remove squared and everything is squared away. So what she did, that is scientist wrote E is equal to MC squared. So she thought this square is also to be removed. And she put it MC7, MC4 and all other kind of things. So observation becomes the key to inferences. And if we can make the inferences properly, we can move further. Again, it got stuck. Similarly, again, this observation. Again, I will give chance to all the participants to observe that what would have happened here. Maybe the goat is there. This branch of tree which has fallen is there. You can observe so many things, and inference is very important, that from observation, what kind of inference you make. And to your surprise, let me tell you that the inference is that child got into this water body just to play with boat. The boat is there, because most of the people would have thought, and I can see that, yes, the child was trying to reach the tree, and from the tree he has fallen because the branch has also fallen, but you could not see minutely small things. Similarly, these questions are always valid questions. Again, see, this is again one important activity, ice-breaking kind of activity before I get into the design thinking. This truck got stuck in this tunnel. This was actually an overbridge, and below this truck was stuck. Now, there were many instruments, and these were available. Many equipments were available, even crane was available. There were various laborers also available. And this truck was not able to move forward or backward. Now, how can you help this truck to get out? Put in the chat box, please. Yeah, I can see few people are raising hands also. Just put your answer in chat box. Is chat box open, ma'am? Gargi ma'am, chat box.
Yeah.
So, yes,
Yeah.
sir. Chat box.
Chat box is enabled. Okay.
So for the timing,
the chat box.
enable the
Gargi,
chat box.
No, open the chat box.
Sir, if you open the chat box, there will be a the lag which sir is facing now. Shifting the PPT, that will get enhanced. So that's why I have disabled the chat box.
No,
but
nothing will happen. Nothing will
yeah.
happen.
Open it because he's asking questions, and yeah, it will make sense, you know.
The questions have to be answered to make it.
Open it.
I've enabled the chat box.
Okay, that's good.
Yeah. Doctor sir, I am unable to see chat directly, so you can see what kind of answers.
No, people are writing it now. Yeah, they're coming up so many. Yeah, remove. They say deflate it. Now it is coming, flowing it. You know, Jeff.
Correct.
Yeah,
Correct.
deflate tires. Yeah.
Oh, very.
Puncture. They're saying puncture it. Somebody is writing puncture it.
So there were various kind of solutions for this, and I asked in this one before also, and the best solution was just deflate the tire a little bit. And
Yes.
all these instruments and all these things are not workable. And there was a small boy you can see in the picture. He said, just deflate the tire. Tire ka hawa nikal do.
Yes.
That is the out of box thinking. Sometimes it's not necessary that every big problem needs a big solution. Again, in a factory, this was a toothpaste factory, and toothpaste factory, what was happening, that this factory faced a problem, that few consumers were complaining that they received the box without the toothpaste. There was no paste in it. So the company had a management meeting, and a lot of things were done. They tried to automate everything, but basically in automation also they spent a lot of money. One day there was no electricity, and after that, so that's why this automation was not working. And the supervisor reached to various plants, and he observed that in one plant there was no mistake. So he reached there, that automation is not working, still you are working. And what he observed, that he kept a pedestal fan near this machine. So whenever these packets are coming, if there is an empty packet, this was thrown away by the pedestal fan. So this was a very simple solution. And they invested crores of rupees into getting automation kind of things. So sometimes big problems can be resolved by small things. Again, you will see this jugaad in India. So you will find there are some jugads and out of box thinking which is required. You will see very interesting jugaad. Next one, this one. This is also very interesting. Now, it's very important to move from fixed mindset to growth mindset. Like most of the time, with the most of the problems, and the most important skill to make our mindset is a growth mindset, is that we should not give up easily. Most of the time, people think my potential is actually predetermined. Failure is the limit of my abilities. My intelligence is static. I avoid challenges. I stick to what I know. If you have all these kind of traits, then you are fixed mindset. I'm either good at it or I'm not. I will never improve. From this mindset, we have to move to the growth mindset, that I like to try new things. I can learn to do what I want. Failure offers opportunity and growth. I learn from feedback. I keep trying and never give up. I'm inspiring by others. My mistake help me grow. Then person can improve. Next thing is in design thinking, please in your classes, focus on human values that facilitates initially to relate their ideas and thoughts with values, craft clarity, and show, don't tell. Most of the time what happens in classes, we tell them and we have a lecture method. Instead of that, show something to children and tell them, ask them to ask questions, let them think. Most of the time in isolation and group, to design their own ideas and self-evaluation during group discussions will certainly improve their thinking ideas and their thinking dimensions. So a critical thinker ask pertinent questions, assesses statements and arguments, is able to limit a lack of understanding or information, has a sense of curiosity, is interested in finding new solutions, is able to clearly define a set of criteria for analyzing ideas. So these are all characteristics of a critical thinker. Yet, as I said, this is time to move from knowledge acquisition to knowledge construction to knowledge application. And now we should think about the new knowledge creation. This is design thinking flow, in which, first of all, we have to empathize with the problem. This means we have to ask if there is a problem in the school, there is a problem in class, there is a problem in day-to-day life. Like in human life also, we have design thinking. Suppose we are getting late almost every day in the office, and our boss is having certain kind of problems with us, and he is complaining why you are coming late. Now design thinking says, go back and try to empathize with yourself and define an ideate. One simple idea is that this person started in the night everything. He chose that this dress I will wear, these shoes I will wear, these socks I will wear, this is the hanky, this is kept over here, this is something else. which is to be planned. This is the tie, because most of the time in the morning, 5 to 10 minutes goes with that, and he can improve, and he started going on time to the office. So in day-to-day life also, we can follow this particular process from empathize to define. So with every problem, as I will move to next, which will be idea, will give you the idea. First of all, looking at every problem, we wonder. For example, in lower classes, I started design thinking very interestingly. And in class 1, I told children that this is one particular card which you have to pull and push. And by pulling and pushing, you have to identify which one is easier. Same card they pulled and pushed. And they said, sir, pulling is better. I said, now tell me idea that these arms of this particular card are smaller. If we make it bigger, then there was a bigger card. There was a same size card with a bigger handle. He said, sir, it has become easier. Now see, this way child will start thinking. Now bigger, if you further bigger these arms of this card, this will be better. You would have seen, many of you would have who visited Kolkata, you would have seen that there are rickshaw pullers. They themselves pull up these rickshaws. And when one person is pulling the rickshaw, you will find that, okay, these arms are longer, that's why he's pulling. So from that, it goes to investigate. You know Pythagoras theorem, but how to use that Pythagoras theorem in day-to-day life is very important. I tell children that, okay, find out what is the height of this particular, say the window from the floor. So they try to find out in class 6, 7, 8, 9, wherever we introduce it, by taking a thread and taking that thread and just finding out that how much is this area from this particular, this length from this particular window, and on the basis of hypotenuse, they can find out. Or investigation is related to observe, infer, and research. And from that, you can examine and compare and construct the theory. Then you can reflect. And sometimes at every process, at every step, if you find that desired results are not obtained, then you can go back to wonder and investigate. For example, I give you one more example, that whenever we talk about certain kind of things which are different, like for example, I said, okay, in tea, whenever you are preparing tea, how you are preparing tea? Are you preparing tea in the kitchen by putting up everything in that particular vessel which you are using? Or you have a process that first you will boil the water, then you will put up the sugar, and then you will put up the tea leaves. So if we find the answer, like for in chat box, if we find the answer that what is normally you do you put up everything in water and then pour milk and tea and sugar, everything, or you do another way? In chat box, are there some answers coming? Gargi ji or somebody can tell me some answers?
Yes, sir. People are saying they put in everything together. Someone
Very
has
good,
answered.
very good. So here Dr. Brajesh Pare will have a big objection because it is chemistry.
Yes, sir. No objection, please.
If you will put everything in the beginning,
yes,
then
sir.
the boiling point will increase.
Yes.
And of course, the aroma of tea will not come.
Yeah.
The aroma of tea will not come, then it is useless. And rather, there will be certain kind of bad elements. And there can be some kind of side effects with tea. And that's why most of the people are not enjoying tea. When they enjoy tea, then there should be proper aroma. There should be sugar. So there is first let boil the water, then put the sugar, then at the end put. Now this is simple observation and children observed it. I gave this as an holiday homework and children wrote it and I said observe it. And from observe, make a system and construct the theory, express it, resolve it, and try to act further. Beautiful. Now, how we make the curriculum creation. This is very important after this new education policy, that students must see that review curriculum and past learnings, whatever is happening, to gather inspiration and then making mind maps. While making mind maps, you involve children, you involve teachers, you involve subject experts, and you move from mind maps, like gather resources, explore new ways to teach, refine ideas, to curate, like translate your brainstorming session into 3 major categories: purpose, measurement, instruction. And then from that move to prototype, and prototype to try. So this particular concept is actually was used in most of the corporates and universities. But then now in most of the schools, Scandinavian countries who are doing great in PISA and every international examinations, they are using this particular method of design thinking in education. And even while preparing curriculum, if you will take and you will give emphasis on these kind of things, certainly things will improve. Now, what children need? They need a teacher who gets them excited about learning, a teacher who smiles and make them enjoy coming to school each and every day. So, basic idea behind this whole concept of 21st century is that we have to develop certain kind of skills, as I said about 4C, moving from knowledge acquisition to creation of new knowledge, as well as design thinking, competency building, and putting up certain experiments, certain ideas right from beginning. We can always observe good results. So my ending remark, my concluding remark will be, please keep your concentration on observation. Take maximum observation from children. Even in lower classes, you are taking to garden, tell them to observe. And from observe, move to inference. What kind of inferences they are making. After making inferences, tell them that what is the conclusion. And by this continuous process of brainstorming, they can come to understand with logic. And if there are few mothers and fathers, of course, all of you are parents also, at your home, when your child is young, just 3-year-old or 4-year-old or 2-year-old, please do not use the word don't. Because don't stop the inquiry. Don't stop the reasoning. Rather, instead of that, tell, don't do this. If you will say, he will do again. But say, if you will do this, this will happen. Then child will not repeat and will understand this is the reasoning. And the continuous process of learning will go, that is how to learn. Thank you, sir. If we have some questions, now I can see chat and everything.
Yes, sir.
We have some raised hands. I'll be unmuting them now. Cynthia Bajum, you may please unmute yourself and ask question. Mithilesh Sharma. I'm not getting a response from them. Dr. Pare?
Yeah. Okay. So it was a, any question, like a lot of hands are raised.
Yeah, hands are raised, but you may unmute yourself and ask the question.
Okay. So
They are only praising.
okay, yes, sir. Yeah, a lot of things coming up. Yeah, really. Anyway, but sir, there will be questions. We can send it to you definitely. And so I'm extremely thankful to
I can see one.
to Mr. Epi Sharma for having given a wonderful and mesmerizing talk, sir. Really, it was very good. And the way you, developed the whole talk, that was very wonderful. You started from the need of the soft skills that will always remain to be there. As long as the humanity is there, it will be there. Human touch, that is very important. And you just praised the need of the paradigm shift, from the fixed mindset to the growth mindset. The purpose of education you nicely touched upon. Then from acquiring knowledge to the construction of knowledge to the application, and then ultimately that is the creation of the knowledge. That is the wonderful thing. And how you sum up the thing that is from observation to inference to conclusion. That is the real meaning of education, and that is what is required in the 21st century, because now more challenges are there and gone are the days of the rote learning and the recall based kind of things. Now the critical thinking and problem solving has to be given emphasis over everything. And your talk was very interesting, sir. Everybody enjoyed it, and myself and all the participants. So please keep guiding us, sir. And thank you very much for sparing your valuable time and your energy and your knowledge. Thank you, sir.
Thank you.
Your blessings are required.
thank you for giving opportunity, Dr. Pare, and it was very interesting. There was some kind of teething problem in the beginning.
No. But this is all, see, sometimes but it's online kind of thing. But sir, I'm so happy, almost teachers from 60 countries. They were listening to you very patiently, and they have given very good, things, and we will share it with you soon, sir. Thank you. So nice of you.
So now, I thank you, Mr. Sharma. And now moving on with our program.
Oh, you're coming up.
So this is our third event and the one we are most excited about, that is the Wizard and International Short Story Writing Competition. This is an event which is truly built for today's generation. We see the children, how they are lining up their creative forces along with learning the technical subjects. We see young YouTubers, people who are writing their novels. So this is an effort to give them a platform to showcase their talent on an international level. In the Wizard, we'll be focusing on developing the 21st century skills of creativity, communication, and collaboration. The student will have a range of topics to choose from, including science and technology, some current affairs, including topics like COVID-19, and also they can write on pure fiction. So their stories that they write will be published in a booklet format, which will be available. So this is a very good opportunity for students to get published at such a young age. This is again an online proctored event. So any student from anywhere across the globe can participate in it. Students of ages 10 to 16 are most welcome, studying in grades 5th to 10th. You can always visit our website. The event will be in December, dates being December 19th and 20th. And to take forward our message for the story writing event and the importance that story writing has in for teaching small students and in their learning, in developing their learning abilities, we have Dr. Paul Stroop with us. I would give a brief introduction of Dr. Stroop. He is a senior lecturer for social science at Endeavour College of Natural Health in Adelaide, Australia. He has been a science educator for over 45 years and has published over 30 papers in language and education. He did his PhD from University of Tasmania in 1986 and was the founder of Short Story in Chemistry competition of the Royal Australian Chemical Institute's Chemistry in School Week program, which went on for 5 years. His book, Body Works Chemistry and Physics for Health Students, is now in its 4th edition, and he is also the author of Properties, Reflections from the Science Lab, which is a collection of 8 essays that reflect on the interlay between science education, the sciences of matter, and humanities. I now invite Dr. Paul to please enlighten us with his experience of these long years.
Most welcome, Dr. Paul. Most welcome.
Thank you very much. It's a pleasure and an honor to be here and be given the opportunity to speak to so many teachers from so many different places, an opportunity to share with you some of the ideas that lie behind the short story competition that we ran, and to reflect on some of the things that I've heard today. Dr. Sharma and Dr. Lee have provided some very excellent and pertinent background information to sustainability and the role of the schools can play. And what I'd hope to do in my presentation is to contribute a small piece to that puzzle about how we can change the way students perceive sciences and the way they work with language. I will try to do some screen sharing. I'm not sure. Can you see that?
Not yet.
Not yet. I will try once more. Share.
Yeah, coming up now.
There we go.
Yes.
Just because I'm sure I'm not known to any one of you at all, the Endeavor College of Natural Health is the largest educators of people doing complementary medicine within Australia. So we have students doing naturopathy, acupuncture, traditional Chinese medicine, nutrition, myotherapy, etc. It's a experience and research-based series of courses providing bachelor's degrees in this area. And the reason I thought I'd mention that is because the complementary medicine field, of course, has got a holistic idea in its background, where we treat the whole person. And that includes the physical, the emotional, the social, and the spiritual. And it seems to me that one of the skills for the 21st century is to find ways within our schools to bring all of the components of what it means to be a human being together. And so that we deal with the child as a whole and not just as a, for example, a receptacle, which we will fill with information and knowledge, but will be an active participant in the whole range of the experiences and reactions that it takes to be a complete and flourishing human being. So what I'd like to talk about is, as Dr. Brijesh has encouraged me, is to talk about the importance of story writing for students in school, some reflections on how that might develop some 21st century skills, particularly the ones that Dr. Sharma introduced a few minutes ago, and my reflections on what the teacher's role might be in inculcating such skills among the students based upon the experiences that we've had. If I can pause just for a moment, Dr. Sharma's presentation made a point that I'm going to emphasize later. He told us a lot of interesting things, but one of the things that I remember already and will probably be using as an example in my own teaching later on was his story about the lady in the bank with the robots. When we tell stories like that, they're memorable, they're easily recalled, often they're humorous, they allow us to reflect, and they say something about the way the human mind is structured. It's I guess the word is a proposal, but I think it's turning more into a certainty from neurosciences in particular, that we are structured for story. We have the idea somehow in our mind that the world is experienced best when presented to us in story format, by which I mean there's a beginning, there's a middle, and then the end, something quite as simple as that, which has a point. If you try and work without that kind of a sequence, meaning is often lost. And so if that's true, that we do have in a sense, being wired up for story, then it makes sense to allow students the opportunity to work with story, to engage more meaningfully with the materials at hand, and to give them the opportunity to self-express their understanding of that material. Why story writing? Okay, I've put some references at the end of this. I feel like I'm just talking to friends here at the moment, so it's just not going to be necessarily all that academic. So I just want to chat with you. My experience and research that other people have done, and many years of talking with experienced teachers using stories in their classrooms, suggest to me the following. That when information is presented in a story format, by which I simply mean the whole idea of a narrative, telling a tale of some kind, which has a beginning, middle, and end, or some kind of a resolution, seems to improve the storage of that content in memory. When people have come to a lecture, days later, what do they remember? Often it's a story that was told by the lecturer somewhere along the course of the lecture. The information is probably there somewhere, but it's not as easily recalled. But stories, because of their structure, do seem to be more easily recalled, even after significant time has passed. Now, storytelling will also, I believe, contribute to the important idea of scientific literacy. Now, scientific literacy has been discussed for decades. We've all been anxious that our students become competent at reading, understanding, and using materials that they have been asked to read, whether they come from textbooks, and now, of course, from other sources like blogs and the internet. And of course, the only way they can do that is if they mastered, first of all, the content, but they also have to master the language. Obviously, scientific information is presented in textbooks in specific ways. And students have to be helped to learn how to read that particular language. And science teachers, in cooperation with language teachers, have a fundamental role to play in getting students to be able to do that kind of reading. Now, if you're not scientifically literate, you're in deep trouble, and I'll talk about that more in a little bit later. But it's an important idea for any sustainability ideas, because without people being scientifically literate, Professor Lee won't have the graduate students that he needs to carry on the excellent work that he's doing. And we won't have the citizenry that we need to make informed decisions about the changes that are going to be occurring in time due to science and technology. A third important idea behind storytelling is making connections. Now, the connections I'm speaking about here are between the world of the scientist, people like Dr. Lee, the work that he's doing, and the world of the student. Now, he's a practicing scientist. That's what he does for a living. He breathes, lives, and eats that particular discipline. He's an expert in that field. The world of the student, of course, is very different to that. And so we have to find ways of getting the student to interact with the world of the scientist in a way that makes that world of the scientist not seem remote. In other words, it makes Dr. Lee as a person more visible to the student, because he sees the work of Dr. Lee in the form of a story in which he can understand and make connections. In the past, there's been a feeling, hasn't there? Would you agree that many students have found the idea of being a scientist a difficult one? They have no real conception about what a scientist does all day, how discoveries are actually made, what goes on in a laboratory. Telling the story of the discovery process as well as the final product using story writing would be a valuable contribution to making the link between the ordinary world, if you like, of the student's daily life and the world of the scientist. The fourth point is one that I've touched on a moment ago. It does seem to be the case that narrative reflects the way the mind actually orders experience. If we put things in the format of a story, if we give them a sequence, we often find that it makes more sense to us. The information then becomes more easily placed in connection with information that we already have. We can see connections to other types of experiences besides just the scientific, and I'll reflect on that a little bit further as we go along. And the final point on this slide, narrative as a crucial activity in the development of a self. And I've put self in capital letters there because I'm talking about the person as a self. There's a lot of work being done about letting people have their say, tell their story. People want to be able to be heard. And when we listen to what they have to say, what they're actually doing is reflecting to us who they are as a person. So the stories they tell about themselves is really a very good window into what they are as a person, what they believe, what their ideas are, where they've come from, how they make sense of the world that they live in. Now, if that's true, there's two important points that come out of that. One is that we can use the idea of a narrative self to change who the self is. And there is a growing interest, excuse me, in the idea of what's called narrative therapy, where we get people to try and deliberately change the narratives that they tell others about who they are. And if we do this successfully and move them from a negative self-image to a positive self-image by reframing the stories that they tell, then we are making improvements in them in terms of things like their emotional balance or psychological state. That's a quite might be seen to be a little bit remote from our particular topic here today. But the idea behind it is who you are is reflected in the stories that you can tell, mainly stories, in this case, about yourself. Now, if you talk about story writing in science, what that means is now you have given the student an extra story to tell. They've made it their own story. They've had to do it themselves. And so therefore their concept of who they are has been broadened. It's been widened. They now feel that they have another string to their bow, to use an old analogy. They can not only talk about romance, they can not only talk about solving a mystery, they can no longer just talk about financial problems. Now they can tell us a story about magnesium. They can tell us a story about where a meteor comes from. They can tell us a story about a dinosaur. They have new things to tell stories about. And that makes them a broader, richer, and more well-informed person as a whole than one who cannot tell those stories. It's also reflected in the fact that if you don't have those stories to tell, then of course your ability to contribute and participate in the society in which you live in an active and meaningful way is also going to be affected and diminished. So the more stories we can get our students to tell, the better able they are to participate more fully in the society in which they live. And of course, that will be an important skill for them to have in any century where they become not victims, but participants, informed participants in what's actually happening in the society in which they live. Now, scientific literacy to me in the past has mainly focused on reading, getting them to be able to read the textbook, read the material, the lecture notes, reading the journal articles, etc. That's important, there's no doubt about it. My concern became more interested in the act of writing because it's obviously very, very different to the act of reading because it makes very different demands on who you are. Now, in our case, we wanted to, I say our case, I'm sorry, I should have jumped ahead. I'm talking about the short story competition in Australia. Our intentions were to get them to write stories that were fictional, but had to have real world chemistry in it. Now, the reason we wanted them to do that, because we wanted them to use certain skills that are more important in fictional writing than the skills that they might have been called upon to use, for example, in writing an essay on the discovery of oxygen, or an essay on the use of or dangers of acid rain on the environment, whatever that might happen to be, which were more about demonstrating a knowledge and conveying information in an objective and terse and precise way. But in fictional writing, the skills are quite different. You have to find a way to articulate your ideas that will engage with an audience, for example. You want to make the audience a part of and the story in the sense it draws them in. They become interested in what's going to happen. They feel that they understand the situation in which the characters are found, and they will begin to wonder how they're going to resolve those, etc. Now, all of those those components of stories require some very specialized skills. They have to think about, all right, what sequence should I put the ideas in? Do I obviously have a beginning, middle, and end? But we know some stories start with almost like the climax, and then they tell you how you got up to that point. Some stories start right at the beginning, work their way through in a conventional sense to an ending. Some leave you hanging at the end. There's a whole notions of sequence become involved. What is the best way to actually tell the story? And the third one, of course, in our case, we had to find that, so the students had to find a way to link the real world with the possible world. Okay, the possible world is the world of the story. And you have to find ways of talking about an imaginary world, a world that doesn't really exist, and a real world, which is that going to the world of the story writer. Now, to me, all of those are very much skills for any time. But as the information available to people in the 21st century through social media, different types of televised and blogged and whatever, thousands, I guess, of different ways of communicating, these skills become far more important. So my emphasis in terms of our short story competition was to get the students to concentrate on the skills of writing. And that was the most important part of it. As long as the chemistry was fine, we were really more interested in how well they could incorporate that into a story, because we felt A, the skills, and B, the outcome of being a storyteller about science were definitely worth our time. Okay. Without this, we have a functionally illiterate society. I'm not going to spend much time on this, but I think it's an important point to make. We're now living in everywhere in the world, with few exceptions, I suppose, in a very highly scientific and technologically orientated society. And a lot of things that are happening around us involve being able to make intelligent decisions about viewpoints on science and technology. If you don't have that, because you haven't been involved in the act of using the science in all aspects of your life, not just in school or even in your profession, but in all aspects of your life where decision-making and the important critical thinking skills that Dr. Sharma talked about before, if you're not doing those, then there's some dire consequences, in my opinion. One is, of course, you're no longer going to be able to be as powerful a political voice as you can be if you were well informed. Politics is based upon power, and the people who have the knowledge are the ones that have the power. And the more knowledge you have about a whole range of things, and your ability to articulate that knowledge to others in a social context of one kind or another, will influence the power, the political power that you can wield. Two, if you don't have any knowledge of science and your ability to participate in decision-making that involves scientific issues, then of course it can affect your social standing in terms of the employment that you can have, in terms of your ability to be an active participant in the citizenry, in terms of voting and advocacy or whatever it might happen to be. Your career pathways are obviously limited, and you're not going to be able to make the most informed decisions. It puts you at a greater risk of being misinformed and gullible. And if I can give a little example here, the current president of the United States has been said in the media and out loud that if hand sanitizers are good for eliminating coronavirus on your hands, maybe it would be a good idea to ingest it and get rid of the coronavirus internally. Now, people who are not scientifically literate and are gullible, some of them in New York City at least, ended up in hospital because they tried drinking disinfectant. So there are some severe practical consequences of being scientifically illiterate at that level. And the final point on that slide was cross-disciplinary opportunities are something we're always looking for in education. We don't want to keep the activities of the science lab completely distinct from the activities down in the language section or the arts section. And that refers me back to my point at the beginning about holistic care. This is holistic thinking, holistic education, which tries to make all the connections possible between all areas of the curriculum. All right, more specifically, Royal Australian Chemical Institute short story competition. A few little information. It ran from 1989 to 1995, which shows you that Rajesh is very good at digging up old articles, because he managed to go back almost 30 years here to find the articles that we wrote about this particular competition. Well done, going into the archives. It was run Australia-wide, and how it was done in terms of the logistics, informing people about things, etc. All the Royal Australian Chemical Institute handled all the paperwork. They organized the prize money, that sort of thing, and they published the winning stories in one of their publications. We had two categories, years 7, 8, 9, and years 10, 11, and 12. The reason being, it certainly seemed to be unfair that a year 7 student would be competing with a year 12 student. So we tried to minimize the discrepancy in ages and skill sets by putting 2 categories. We did not supply any set themes, and we did not set a word limit. So they could choose any theme they liked. We did that for a deliberate reason. We wanted them to not feel at all confined about the choices that they had available to them. They could write about anything that struck their mind as interesting that they would like to tell a story about. We didn't set a word limit, and looking back, that might have been a mistake. We didn't get too many over-the-top stories, but we did get some that ran into thousands of words as people got really involved, which meant for a lot of reading, but it still seemed a better idea not to say you must complete your story in 750 words, because that again might put limitations on the ability of the person to be as creative as they'd like. We obviously working on a much smaller scale than you will be. We had roughly 200 entries per year. And so it made it easy enough for the markers to get together and have a look at those. So the logistics were not very difficult. But if you start talking about thousands of stories, I'm happy to turn that over to Brijesh to deal with. That'll be a very interesting experience for him. Each story had to be read at least twice, and often more than twice. In our case, once by a chemistry teacher and once by a teacher of English to check for the story components. And I'll talk about both of those now. Chemistry. Obviously, the chemistry had to be accurate. It couldn't be science fiction chemistry. So it had to be a chemical reaction or a process or a characteristic of an element that was known to be the case and couldn't be made up. And secondly, it had to be central to the story. In other words, it couldn't be just a whole story about Mary and Tom having a romantic relationship, and then the very last sentence was, and then they celebrated with a chemical reaction or something like that. The chemistry had to be central. But it didn't have to focus on a chemical reaction. That might be the first thing that would come to mind for many students, but well, that's what we assumed, but in fact it wasn't. Many stories were told from the perspective of a piece of apparatus. So you had stories like, my name is Tom, I'm a test tube in year 7 chemistry, or I'm a magnesium atom, and here's the story of my day. So it could be a fictionalized piece of apparatus or a piece of a molecule. Some people put it in the form of a chemical history story. So discovery of oxygen, they would have Lavoisier coming into a room and telling his friend Jacques the experience that he had that day and what he felt that he had discovered. And some people took it to the social, environmental, political significance of chemistry. So they talk about the chemistry of acid rain and its association with the difficulties of pollution, and then what would happen from there. So the whole gamut, if you like, possibilities was available to the students, and I'm delighted to say that they really took advantage of that. There was an enormous range in the type of stories, the genre of the stories, and therefore associated with that, the interest of the stories. We were reading a lot of different things. Judging the story content means that we needed to have a literature or language teacher, obviously, but they should have experience with what a writer in any particular year level is capable of in terms of the skills they would have already learned at school, the practice they would have had in writing different kinds of stories, etc. So they would have to say, look, I know because I teach what a year 9 student's story level, I can get a feel for what they're capable of. And so that is a very important point to start from. Obviously these students were writing these at home, in many cases, and you wanted to be sure that the story seemed to be reflecting their ability level and wasn't in fact written by someone who was a more experienced storyteller in an attempt to get a higher achievement. So when the English teachers got together with the science teachers, the questions they asked of the story as they read it was, is there a recognizable author's voice in the story? Can you see that the author is a particular type of person, a particular type of character? Now, the author's voice is a matter of style. And so the voice of Hemingway would be very different to the voice of Faulkner, to the voice of Emerson, to the voice of Dan Brown. And what that would be something we would be looking to see whether or not you could distinguish the type of author who was writing this story. Does it have well-developed characters in any sense? So are these characters believable? Do they have motivations that are understandable? Do they have dimensions to their character? We were opposing that to the idea of the one-dimensional or stereotype character, like the classic villain from the Marvel movies, for example, who's only evil and is just single-minded about something, or these people have got more richer personalities but still remain believable. Do these characters show development over time? So in the course of the story, do they learn something new? Do they change their minds? Do they react to the situations that they're in ways that shows the development of their personality, of their moral sense, of their skills of one kind or another? Or does that not change?
Yeah, 15 candidates. The first child is Sridevilas Verma.
And the other one is their authenticity
All
in the
are for
story.
grade 4 admission.
Does it have...
sorry, Paul, someone that has
there you go.
muted themselves. Yeah.
Okay. All right. I'm not sure where to pick up from,
Yeah,
but do they show development over time? I'll start there. Do these characters? Yes, is that right?
Let us go. Let us. No, you should continue, sir. Sir.
Yeah, I will. And do
Yes,
they show development over time or not? And do they react to the situations that they're in by demonstrating change? They learn something, a new skill, their mindsets change, they become more positive, whatever it might happen to be. And is there authenticity in this story? So that the whole thing works all the way through, it's consistent, so that they're not all of a sudden in a situation where something from the past intrudes into the present, which would be science fictional, or something that would not have occurred in that time frame is taking place, so that they're talking about, let's say 1850, and they're starting to someone talks about the explosion of a hydrogen bomb or whatever. And so it has to be consistent all the way through, and it has to be authentic. Now these sorts of criteria are best judged, of course, by the English and other the language teachers. And so there had to be a dialogue between those teachers and the science teachers in order to properly judge these stories. So we had to ask the question together: has the chemistry been integrated coherently into the story? Okay, or has it been clumsily added to meet competition requirements? So the chemistry component must be an integral part of the story. It has to make sense. It has to flow with it. It can't be just added in any particular way. And that's a dialogue that had to take place between the science teacher and the language teacher. And we had to ask together in collaboration, can the author write about chemistry in the same language they use to tell the story, or is there a mismatch? Now, the interesting thing here is that some stories were written in such a way that the first part would be two characters interacting and talking about something, and they realized they needed to know some chemistry or do an experiment to answer a question, to enter competition, to solve a problem. And then all of a sudden, when they started talking about the chemistry, it began to read like a textbook. Okay? So the language shifted. It became a technical language inconsistent with the language of the story. So that would be considered to be a flaw in terms of the criteria that we're using for judging. Now, just a couple concluding remarks here is that we believed in our case that students had to be given a reason for writing these stories beyond just winning. So the teachers had to say, look, here's an opportunity for you to do a couple of things. One is maybe to win a prize. Sure, that's cool. Secondly, though, here's an opportunity for you to challenge yourself. Do you have what it takes to write such a story? Do you have the skills? Do you have the interest? Do you have the ability to write a story which is fictional, but contains something that you might not never have believed would be part of a story, some chemistry component in our case. This type of challenge, many students rose to it and found it an exciting thing to attempt. They liked the idea of being given something new to do. And the other reason, of course, was that it allowed them to realize, and the teacher should point this out if it's not clear to them, that it allows them to do something which is cross-curricular. And it shows them that what was going on in the science classroom could actually be made to relate to things that are going on, in our case, the English classroom. And students in the science classroom who thought English was more important jumped at the chance, and the science students thought, all right, here's a chance for me to show those English people that chemistry really is interesting and can be talked about. Judges are going to have to talk with one another, and they have to agree on what it means to meet the criteria. Now, the list of criteria I gave a moment ago may or may not be the ones that you adopt. But whatever it is, it has to be obviously applied consistently among all the judges to all the stories. And so that dialogue will have to occur at some stage just to make sure that that happens. The stories must therefore be read by more than one person. That's my view anyway, and the view of us here when we read it in Australia, because you need the varying viewpoints of the perspectives of the experts in story and the experts in chemistry to ensure that things are being done in a way that allows the criteria and the meaning of the competition to occur, which is to do all those things that we talked about before in terms of literacy and cross-cultural fertilization, whatever. And we also believed it was important to give feedback. So they had to know, did they meet the criteria, yes or no? Was the chemistry right or wrong? Yes or no? Tell us what we thought about the story, and providing the feedback we thought was absolutely crucial. And we believe that that's one reason why many students participated year after year, even if they didn't win a prize, because they thought they were improving because we got the feedback that they got. So finally, I'd like to wish you all the very best of luck with your competition. It's an exciting venture. It will provide you with some fantastic stories. It'll open the minds of your students to a whole range of possibilities in terms of writing science and connecting it to the real world. It will open a window into the world of the scientist as well. And more importantly, I think it's a lot of fun and they will really enjoy it. So thank you very much, all of you, for inviting me to have the opportunity to talk with you about this. I know these are difficult times with the COVID, and many of you are probably hunkered down in home with everything that's going on. And so my thoughts and wishes go to all of you and your loved ones in these difficult times. And finally, Dr. Prijesh, I'm still waiting for that curry recipe that you promised me. Or more importantly, my wife is still waiting for that curry recipe.
Once promised means it will be shared with you, definitely, sir.
Thank you very much.
Yeah, thank you.
Yes, Dr. Parekh.
Yeah. Dr. Paul Strum, it's a really pleasure listening to you. And Dr. Paul is known to me for the last so many years. In fact, I got in his contact because of the stories. He has published many very good papers on story writing. And one of the papers, long back, somewhere in 1996, yes. I came across, and I wrote to Paul about the paper, and Paul had sent me the paper, the hard copy in those days, and it was lost somewhere. Then recently, again, I thought of Paul and I wrote to him, and he sent me the soft copy, but this time he got the help of his son for getting it scanned and all that, So he's such a wonderful man, so much, loving, and he was so passionate about story writing and all that. So when we talked to him, sir, that we are planning such a program, and who could be better than you to just come and to give the blessings and the talk. He agreed for that. And when I was listening to him, that shows, how, in fact, sir, the story is integrated with you, rather, the story writing, the way you are speaking, because you have done it for so many years, and we have noted all the points, all your suggestions. Certainly, how the story writing is going to build the scientific literacy. And this is a wonderful thing. Like you can, the subject teacher, not necessarily science. It may be science, but the other subjects also. So the subject teacher and the language teachers, they have to collaborate on that. They have to collaborate. Yeah, in order to inculcate the interest among the students, that is the first thing. And later on, to organize and execute the whole program. And just up to the criteria of judging, how to judge a criteria. Because when there is a story, so there is the language part, there is the content part. So together teachers will have to sit and then they will have to judge. The criteria you have given were wonderful. And the need of 21st century, what, sir, you are working still today, for so many years. You started long back, but it looks to be more relevant, today also, when we are talking about 21st century skills, we are talking about critical thinking, we are talking about, the creativity, collaboration. So all story writing will definitely bring, those things, definitely will prove very, very useful in inculcating these kind of critical thinking among the young students. And the concept has to be integrated with the content. That is something very, very important. So, sir, thank you very much. And we had a very, very passionate listening. We enjoyed listening to you. And you were talking to, say, the teachers from more than 60 countries today. And your message will go very loud and wider. So keep blessing us, sir. Keep guiding us. And stay with us. And the promise of that, the recipe, that is between you and me. And I will not disappoint you in any way. So thank you very much, Dr. Paul. Thank you, and keep blessing us, keep guiding us. Thank you very much.
My pleasure.
Thank you, Paul. And I thank you, Dr. Pare, as well, for always being the guiding post that you are. And reaching out and communicating with all these great academicians and pedagogists from across the globe and bringing out great content for our teachers who are attending today. Now, I would like my co-founder, Kaustup, to step up and just sum up the whole event for us. It's just taking him a second and he'll be here.
Okay, so it was a pleasure to host all of you. And first of all, I would like to thank Dr. Adam Lee for his presentation and insightful speech that he gave. The best thing I liked about his presentation was, that the things he quantified into, that you could actually see it in terms of tonnage, in terms of the economics that he had used. So that was the best part that I liked about it. Second was Mr. A.P. Sharma. He is a seasoned person. He has always been a guide for us, and he is been his blessings are there with us. So we are moving forward in that direction with his help. And third, Dr. Paul, he has been somebody who is helping us with our programs and everything. So I would like to thank all three of them. And as far as for you people, you have been an excellent audience. It was pleasure having you everyone here. And all these three events, the Enviro quiz, the Sci-Pi quiz, and the Wizard, that is a short story writing competition, you can associate with Quantum Vault and have us maximize the reach of all these events. And I will be sharing with you the feedback form. So with the help of feedback form, you will get your certificate from there. And also what we are trying to do is reach out to as many people as possible. So these are our social media handles and everything. So you can follow our YouTube channel. This is the same channel where you must be watching. Then we are there on Instagram. and Telegram as well. So you can follow the links and you'd get the live updates there as well. So I would just share the link and it would be open for a couple of hours. So you can fill it up and see you next time with another wonderful session, wonderful speakers, and hope to have a great time again. Thank you. Please, Sunny, enable the chat so I could share the link.
Thank you. Thank you, Dr. Paul, once again.
Thank you,
Dr. Lee
everyone.
and Mr. Sharma. Thank you.
You can also reach out to us via the email addresses mentioned, and you can take down our website. It is a one-stop solution for all of these addresses. We are also available to you via WhatsApp. Even for international contacts, you can always reach to us through this number, and we will get to your problems ASAP. Thank you, and please fill the feedback form so that we can provide you with our details as soon as possible. Thank you for joining us today. Have a nice day.
Thank you. Thank you, Paul, Dr. Paul. Thank you, all the participants. Thank you, Dr. Lee. Thank you, Mr. A.P. Sharma. Thank you. So nice of you. It was a wonderful afternoon. Thank you.
Thank you very much. Bye-bye.
Bye.
Thank you. Bye.
Thank you.
Thank you,
Bye-bye.
Adam.
Mr.
Thank
Sunny,
you.
Thank you.
Unmute everyone now so that if anyone wants to say something as of now and they were not able to say it earlier, then we can unmute all the participants now in case anyone has something to say.
Thank you, Professor Adam Lee. Really, it was really wonderful. Please keep guiding us, and really, we enjoyed. Thank you, Dr. Paul. Thank you, Mr. A.P. Sharma. Gargi, are we getting anything, questions or?
No, I think that's all. I think people can take down the feedback form from the.
So should we call it a day?
Yes, we'll call it a day, and we'll take the messages shared today forward and to the next level. Thank you, everyone, for coming.
Thank you. Thank you very much. Thank you, Adam. Thank you, Paul. Thank you, Mr. A.P. Sharma.
Okay,
so nice
thank you very
you.
much.
Stay home.
So nice of you. Please keep in touch. Regards. Yeah.
Thank you.
Thank you.
Participants are now free to unmute themselves. They can unmute themselves if they have something to discuss. If you have any questions.
Ma'am, where is feedback form?
Yeah.
I couldn't find that feedback form.
Just give me a moment. I'll put the feedback form in the chat box.
Ma'am, I would like to add up. Good afternoon, ma'am.
Yes, hello.
Hello.
I have a question. Hello.
Yes, please.
Good afternoon, sir.
Yes.
This was a very enriching session. I'm a teacher from Pune, a prestigious institution called SES Gurukul from Pune. And of all the sessions so far we have attended, I found your session very, very inspiring and informative. And it has given us a lot of insights to work on. So at this juncture, I request you to, if you can share a few slides on the thinking process, the design thinking, what Dr. Sharma was speaking about. If you could send us some slides through mail.
It is a
yeah,
great.
it can be done, but on website it will be posted. Yeah.
Yes, you can
on the website.
All the three.
Okay.
Yeah.
And sir, I'm really hopefully looking forward for more such sessions with you. I would like to add up, this was one such very meaningful and very apt session. So far, I haven't found even one in all the pandemic zone. I just found yours very, very enriching.
Thank you. Thank you, ma'am.
Thank you and congratulations for inspiring us so much.
Yeah, please guiding us.
Please my name is Srividya Radhakrishnan. I would like to continue corresponding with you, sir.
So nice of you. So nice of you.
Hello. Good afternoon, everybody. Good afternoon, everybody. Sir, this is Ravindra.
Okay.
Sir, this is Ravindra from Bangalore. I'm a big fan of this one, Baba Atomic Research Center. And your today's workshop was to the point. Though I have attended so many workshops where they talk something which does not work out in a classroom situation at all. But all those who experienced learned people came, they all spoke about how can it be achieved in a classroom. That was really good. It was a really very good eye-opener. Thank you so much, sir. Thank you so much.
Sir, good afternoon, sir. Even I would like to add on to what
Can I kindly add, sir?
Like out of so many workshops, what all we have attended, I think how to implement in the class. I think this is this is the best workshop which I have attended.
Oh, lovely, lovely, lovely. Thank you.
I would
so
like to
nice
definitely be in contact with you, sir. How to get your presentations like on the Quantum Vault website?
No, everything will be there on the website. It will be posted there. Yeah.
In the Quantum Vault website.
Well,
Quantum
I have
Vault
question.
website.
This is Ariel from the Philippines. I have a question about
yes, ma'am.
The e-certificate. When will we receive that electronic?
On the submission of the form, you will get the certificate. Yeah.
And then I would like to ask if their assessment or evaluation will be
within a week you will get. But have you filled the feedback form?
Feedback form is in the chat box.
It is on the chat box.
All right. Thank you very much.
Yeah, please fill the feedback form. Yes, ma'am.
Yes. Dr. Pare, I am Charu Arora, PGT Chemistry at Ramja School, RK Puram, New Delhi.
Yes, ma'am. Yeah.
Sir, I would like to compliment you, congratulate you for such a wonderful session. I would like to agree with what my, fellow teachers have said. It was an absolute, relevant, pertinent to the topic.
So nice of you. So nice of you.
And sir, the latest thing that has happened in CBSE, the integration of art in curriculum.
Yes, ma'am.
Take away the idea of story writing.
Yeah.
Yes, madam. Yeah.
That will help me integrate art in the curriculum, sir.
Oh, very good. That is what we are planning. See, that is something very good, ma'am.
I mean, learning about selective chemistry and nano-engineered catalysts being used as, sustainable resources. It's a wonderful thing, sir. I will definitely share the slides with my students.
And madam, we all need to, work for sustainability now, no? I mean, to beyond the environmental science, like.
Yeah, I loved every word of it.
Subject. Yeah, thank you.
Very, very relevantly and very pertinently done, sir. Very well done.
So nice of you. Thank you.
Good afternoon. Good afternoon, sir. Sir, good afternoon.
Good afternoon, sir.
Hello, I'm Krishna Kumar from Anandalya.
Oh yeah. Anand. Yes, sir.
Anand. Yes, actually, absolutely. I think one point I think which I would like to add on. Unless and until we need to bring a lot of changes. Hello.
Yes, sir. Yes, sir. I'm listening.
We need to bring the 21st century.
Yes, sir.
Actually, it is not only for the students, but technology are thinking.
For the teachers also. You are right, sir.
Yes.
The question is absolutely right.
We need to change first. We need to bring in
first
changes.
The teacher, sir. For as a teacher, first we have to learn things, and then things will be percolated down, to the.
Exactly. Sir.
Whatever we are doing for teachers, sir, mainly for teachers.
Yeah. Fantastic.
Hello.
Fantastic session.
Yes, ma'am.
Hello.
Yes, ma'am.
Gitanjali, sir, how can we use these techniques in the pre-primary classes? I would like that in the next session. I would like that you should do the webinar on this pre-primary or primary classes.
Yes, ma'am. We'll definitely try to incorporate.
No, the thing is,
How we can
no, I'm happy that you are thinking about it.
Yes, ma'am. Hello. Myself.
Something that
How can we use these techniques in the pre-primary classes?
Yes, ma'am. Yes, ma'am.
I would like that in the next session. I would like that you should do the webinar on this.
Definitely, ma'am. Thank you for your
primary classes.
Thank you for your suggestion, ma'am.
Excuse me, sir. Excuse me, sir. I would like to say something.
Yes, ma'am. Tell me. Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
You should do the webinar on this.
Definitely, ma'am. Thank you for your
Excuse me, sir.
Yes, ma'am. Yes.
Excuse me, sir.
Yes, ma'am.
I'm Anuradha Goel.
Yes, ma'am. Please go forward. Go ahead.
From Bal Bharati Public School.
Okay,
I would like
ma'am.
to say just one teacher, Gitanjali, she said how to add to pre-primary. In the Mr. A.P. Sharma's slides, there was one slide, like it was like just one slide itself would be very effective. Like he showed us how to observe. Just observe like the Archimedes in the tub,
Yes, ma'am.
Newton sitting under the tree, and the steam kettle of a steam observation by James Watt.
No, that is the thing. He was
Those
talking
simple
about
observations itself.
the accidental findings, accidental inventions, no? So, but accidental inventions are only possible when the scientist is aware. He's a very keen, he has a keen observation. Otherwise, anything deviated, the unexpected results will go west, and unless you are very, very keen observant about it. Are you getting my point?
Yes, that is what I said.
Yeah.
Like observing it.
Yeah, you are saying right.
such a
Observation,
simple level.
inference, and conclusion. Yeah, observation, inference,
And then he said,
and conclusion.
some Olympiad person like observing 110 kind of things in that, and even even a simple tea, making of a tea, that you could do like. We put all the things together, but if we started putting one thing at a time, then the tea would have a different kind of aroma, and there's a chemistry behind it.
Yeah.
So at that level, not only children, even the illiterate people will get to know why is it somebody else's tea is better than the other ones.
Hello, good afternoon.
Right. Good afternoon.
Hello.
Hello.
Here. We would like to ask if
एक मिनट रुक जाओ जरा से हवा आ रही है
we need to someone is talking over here. Yeah, please continue.
Hello. Sir, this is Gopa here.
Yes,
Okay.
Sir, I'm not able to submit the form, the feedback form.
So, but it is there on the chat box, click it and fill it and send it.
For the link.
I got the link, ma'am. I got the link. I filled it also, but it is not taking as a submit.
Okay, maybe ma'am, maybe once you end the meeting and then fill the form, refresh it again, it will be available.
Okay.
Yeah?
Good afternoon, Paras sir.
Good afternoon.
This is Kamal Kumar from Etawah.
Oh, my dear friend, what a pleasure. What, sir?
Yeah,
I mean,
thank you.
It's a great to hear from you, sir.
I have attended the whole webinar and really it was very interesting and insightful.
Sir, thank you.
And I'm looking forward to have many more such sessions.
So nice of you, sir. You have always been, Mr. Kamal Kumar have been very encouraging for us all the times.
Thank you, sir.
Thank you. So nice of you. Please keep in touch, sir.
Sure. We are in touch.
And thank you for the kind words. Thank you.
Good afternoon, sir. This is Jaya
Good afternoon. Oh, hi, Dr. Jaya Parikh. Yeah.
Your student, sir. So,
how are you, Jaya?
I'm good, sir. Many congratulations to Quantum Vault team. It was really
to Gargi
great.
and to Kaustuv.
Gargi. It's a huge feat to get such educationists on one common platform and to ensure that the whole
Jaya.
session, from slide to slide, minute to minute, it had such enriching information for educators. It was wonderful. And for the pre-primary teacher, I would just say that the simple experiments with light, sound, capacity, volume, etc., they build a scientific inquiry and a mindset. You can start with that.
Good afternoon,
Thank you.
sir.
Congratulations.
Thank you, Jaya. Thank you. You have always been a good learner. So that's really, that you enjoyed it. Thank you.
Yeah, good afternoon.
Your suggestions are really important to us. Yeah.
Myself, Sajindran from Oman.
Okay. Yes. How are you?
Yeah, fine, sir. And very much wonderful. First of all, congratulations. And
thank you, sir. Thank you.
Listeners are very valuable and very, opening, mind opening.
Okay.
Thank you. Thinking in that way. And really impressive the way all the resource persons have given their valuable time as well as the suggestions.
Yes, sir.
And one thing I just, if you give me permission, I can.
Yes, please.
Sir, in our days, usually, the thinking, what was accidental thinking used to come all of a sudden, because we were having limited resource, and nowadays what you feel that everything is available on the Google and everything. So that's something stopping them to have such kind of thinking. What do you think? I don't know.
No, sir, this is not a critical thinking. See, getting information from Google, that is to be avoided. See, information is not knowledge, no, sir. And see, knowledge is like, you have to make use of information. I mean, from information, you have to go for the analytical skill for synthesis and then up to creation. The Bloom's taxonomy, no, sir. The Bloom.
I agree that. I was thinking saying something else.
Information with knowledge.
No, I was thinking, no, available, that is different thing. Because of availability, I think information is available. Children's self-thinking is somewhere, a little bit
hampered. That is affected. So it is the role of a teacher.
For the teachers, very difficult now.
What Mr. A.P. Sharma was telling, that the role of teacher will never, go down. It will always be there. So that is where, we have to tell them that what you are thinking is knowledge. It is not a knowledge. It is an information.
That is why. So it's becoming more challenging nowadays to convince this generation.
So for teachers, sir, we have to be, now it's a challenging time for us also, no, for teachers also. So we have to keep abreast, with all the information. And then we have to take student ahead of it. That is what is important,
Thank you very much, sir.
Thank you, sir. Thank you. Good afternoon, ma'am.
I would like to ask if, aside from evaluation form, is there other post tests about the webinar to get the certificate?
Certificates, you see, if you have filled the feedback form, within a week you will get the certificate. Yeah.
Thank you.
Have you filled the form? The feedback form? Okay, then you will get it, ma'am. Don't worry. Good afternoon.
Sir, today's session was really very informative and very useful. And
thank you,
we would like to have a session on art integration in education, sir. Like, with the new curriculum that is coming up, it will be very useful for the teachers how to implement art through the curriculum and for different subjects, at least few subjects, main subjects like math, science, and
Could you specify like how?
No, that is, story writing is something very good,
Yes, sir. Yes, sir. It was. But a bit more into it, like a special session for that alone would be beneficial, actually.
We'll
if you can.
We'll do that. Definitely.
Thank you so much.
Sure, definitely. May I know from where you're speaking, ma'am?
My name is Daya Srinivasan. I'm speaking from Chennai, and I'm working as a teacher in the PSBB Millennium School.
Oh, yes. Good. Thank you, ma'am. Good suggestion. Very good suggestion.
Thank you, sir.
Good afternoon, sir. Good afternoon, Pare, sir. Myself, Abhishek.
Good afternoon, sir.
Myself, Abhishek Bajpayee from Reliance School.
Oh, lovely. This is Navi Mumbai.
No, in Jamnagar, Gujarat.
Jamnagar. Okay, sir.
Yeah. Actually, I have got your message also through WhatsApp. Always you motivate to learn the things And about the webinar, it was
Yes, sir.
so nicely organized. Like we can learn all the things and we can utilize in the classroom situation.
Yes, sir. Yes, sir.
Second thing, I humble request to you, sir, please organize the webinar on particular subject. Actually, I am from the physics background. So,
okay.
Yeah, I need you can organize a particular on the pure physics webinar, like the different burning topics, and that will be helpful for everyone.
Yeah, sir. We'll do that. We'll do that.
Once again, thank you very much for the wonderful webinar, sir.
Yeah.
Thank you very much.
Keep in touch. Thank you for the kind words. Thank you.
Hello.
Yeah.
Good afternoon, Dr. Parekh.
Yes, ma'am.
I'm Shiji from the Millennium School, Dubai.
Oh, yeah. How are you?
Yeah, I'm good, sir. How about you?
Thank you, ma'am. So nice of you for coming and joining.
Yeah, it
Hope
was
you had a nice time.
a wonderful session. You know, actually, I have also attended a lot of seminars. That's why initially I thought, okay, this also will be the same. But, you know, it was really fruitful and really enjoyed. So will you be sharing all those slides with us?
Yeah, all. It will be there on the Quantum Vault website and you can easily download it. Yes, yes.
So one more thing, this year we are not planning to conduct the ANCQ.
Yeah, NCQ has been cancelled because of COVID-19. Nowhere it is taking place, neither in Australia, no, any part of the world, you know. Next year it will take place, next year. So this year, you know, that's what, you know, we have this Enviro quiz, we have story writing competition, we have the science quiz we have. We all will be sending you the brochure and other things soon, no? Yeah.
Please share some questions if you have the same pattern questions of NCQ because it was really helpful for students.
Yes.
Hi, sir. Good afternoon.
Thank you, sir.
Good afternoon, sir.
Hi, sir. Good afternoon. Nair here. Very well organized. Very well. Congratulations, sir. I enjoyed it.
Yeah, I was thinking, who is the gentleman? You know, I know the voice. Okay. Thank you for coming, Dr. J.K. Nair.
And very. I send you a personal message also. It's very well organized and very good.
You joined, you know, when Paul was speaking. No, Paul was speaking. You have listened, Paul's. No.
Yeah. No. I had joined earlier also. In between there was some technical problem, but I rejoined.
No problem. No. Thank you. No, because you are a part of this whole thing. You know.
Secondly, Gargi conducted it very well. Now she is Dr. Gargi.
Thank you.
Now she is
Gargi.
Hello, good afternoon.
Now she is Dr. Gargi.
Hello, sir.
Thank you.
Good afternoon, sir. Good afternoon, sir.
Yeah.
Hello, sir.
Hello, good afternoon, sir.
Good afternoon, ma'am.
Sir, this is Priya from the PSBB Millennium School.
Oh, yes. Good afternoon, ma'am.
Sir, well organized, and we were really benefited by this. Sir, will it be possible to organize a webinar for our kids also like this?
For kids?
Yeah, for the students.
For students, which class student, by the way?
Sir, probably from 8th standard, 8th to 10th.
Yeah. No,
because
that can be done.
That would be the right age to understand these concepts.
This is for them only, eventually. Like, you know, if we are talking to teachers, the purpose is, you know, that things should go down to the students.
Yeah, we will take it to the classroom, sir. But still, no, if it is from your end, children will really enjoy.
No, we'll plan something. Definitely we'll plan. Thank you. Yes, it's a good suggestion. Thank you.
Yes. Hello, good afternoon.
Good afternoon.
Hello, good afternoon. I just would like to congratulate all the speakers for sharing their expertise. We really enjoyed the seminar or the webinar. And we hope or we're looking forward. By the way, this is Marjorie Gossa from Puerto Princesa City,
Marjorie,
Philippines.
I can read. Yeah.
Sir, thank you so much. And we're hoping to have more webinars like this. This is very helpful. This is very insightful to teachers like us. Very inspiring as well.
So nice of you.
Thank you so much and congratulations.
Please keep in touch. Thank you for the kind words. Thank you.
I will.
Hello,
Thank
sir.
you so much.
Hello, sir.
Thank you. Bye. Hello.
Hello, sir. Good afternoon.
Good afternoon.
This is Trishna Datta ma'am from Delhi Public School, ONGC Nazira, Sifsagar, Assam.
Oh, and Abha. Where is Abha?
Yes, she's there. I don't know where she's there in the webinar.
No, anyway, but Yeah. How are you?
Yeah, I'm fine, sir. I teach biology.
Yeah,
Sir,
biology. Good.
This was a very nice webinar and very informative, and I liked all the sessions.
Thank you, ma'am.
So one request is there. If sustainability in 21st century, today's topic was this. So if something can be carried on experiential learning at present.
Yes. That is important.
Experiences, learning by doing and involving oneself is very important. It's the need of the hour. Sir, it's if any webinar can be conducted.
No, that is really the need of the hour.
Yes,
and
see,
there are certain limitations for this online kind of thing. Otherwise, many more things can be done. We'll do it. It's a good suggestion. And convey my regards to Mr. Parthasharthi Sarkar. No, he's the principal.
Yes, sure. Yes, sir.
He's a good friend of mine. Convey my regards to him. Yeah. Okay.
Okay, sir. Fine. I'll convey your message.
Thank you.
Sir, very good afternoon. This is Mrs. Sangeeta from Bishop Cotton Girls School, Bangalore. Hello.
How are you, ma'am?
Fine, sir. I'm good. How about you, sir?
Okay.
It was
I'm fine, thank you.
It was a wonderful workshop. And as you have said, the knowledge has to be articulated in a better way. And that is what you have done in this webinar.
Okay.
I hope to see many more webinars. And also, sir, we wanted to know more about the national education policy, which is coming up. And what are the techniques that can be involved in the teaching fashion these days? So if you could just brief about this in the next webinar or so, it will be
why not? Yeah. We are planning on that. Definitely, we keep you informed, and please keep suggesting us, so that we can improve things, gradually, and we can work together.
Yes, sir. And it was really very productive webinars that we have attended so far, because it wasn't moving away from the topic. And it was
really? Yeah. The speakers were really they are masters.
Yes, sir. And those were all very efficient and eminent personalities who spoke.
Yeah, definitely they. Yeah. They all.
Very good. So
thank you for coming and joining us.
Children. Yes, sir. And I'm also very grateful and thankful to you for organizing such webinars.
Yeah, please keep coming. Please keep joining us always. Yeah.
Yes, sir. Yes, sir. Sir,
and keep suggesting us.
The feedback form that I have filled, once I submit the form, again a blank form appears. It means whether it is accepted or it is not accepted.
So just 1 minute. When she's submitting the feedback form, blank form is coming. We will check it. Don't worry. For any other thing, you can just send the message. Don't worry. Within a week, you will get it. Okay.
Yes.
Thank you.
Sir, when you submit
so
the
nice
form,
and
you get a sample of
looking
it in your
forward
mail.
for many more such seminars.
Yeah. Okay, thank you very much.
Yes, hello.
You may WhatsApp any
question. Sir, I have a question regarding the certificate.
Yes.
Since I've already submitted the form, and is it okay? I've used my personal number instead of WhatsApp number.
That is okay, ma'am. That is okay.
All right. Thank you. Thank you, sir.
Thank you. Thank you, everyone, for joining.
हेलो
Yes.
हेलो मैम नमस्ते मैं शीतल बोल रही हूँ SKV GTB नगर दिल्ली के स्कूल से मैम ये सेशन मुझे बहुत अच्छा लगा मैं हिंदी की टीचर हूँ इसके बावजूद मैं इस पे नॉलेज लेना चाहती थी सस्टेनेबिलिटी पर और ग्रोथ माइंडसेट पर तो मुझे ये बहुत ही लगा
अभी तो है ही नहीं आदमी तो क्या देगा इतना दिन तो कुछ
हेलो
यस शीतल मैम
हाँ थैंक यू सो मच मैम हिंदी की टीचर थी उसके बावजूद मुझे सस्टेनेबिलिटी पर ग्रोथ माइंडसेट पर बहुत कुछ जानने को मिला और इसे हम अपने स्कूल में इम्प्लीमेंट कर सकते हैं क्योंकि टीचर या सब्जेक्ट कोई भी हो बट स्टूडेंट को हमें अब इस टाइम में उन्हें कैसे जीना है कैसे लाइफस्टाइल बदलना है कैसे अपने पर्यावरण को बचाना है ये हम बेहतर तरीके से बता पाएंगे
हाँ मैम उसमें लैंग्वेज बैरियर नहीं होना चाहिए थैंक यू फॉर ज्वाइनिंग
थैंक यू मैम
Everyone, I'll be closing the meeting now, so you all can fill the feedback form. The link will be active only for a few hours, and we'll be eagerly waiting for your feedback. Your forms will reach you via email in a week or so. Thank you for joining us today. Thank you.
Thank you, ma'am. Thank you, ma'am.
Yes, ma'am.
Thank you, ma'am, for your sharing your expertise.
Hello, ma'am.
Thank you very much.
Hi.
Hello.
Yes, ma'am. This is Julie Ancleto from Sorsogon City, Philippines.
Yes.
I would like to commend everyone for a very good webinar. And I am looking forward for more talks from Dr. Paul because I love, I am a language teacher here and I love short story writing also. So at least more talks from him.
Yes, that's great, Julian. You can take the message forward in all the Philippines and locally encourage students to participate in the event. That would be great.
Yeah, thank you very much, ma'am. Congratulations to everyone. Thank you.
बैकग्राउंड इसमें कोटे से गुडली उसे मुझे कहता ना गाने वो हुनाई नहीं morning prayer Lord I may be stressed in pain
Thank you so much. Bye.